All right. Good morning, everyone. I am Natasha Pant, and I am here to discuss the physics section of Aakash Invictus test series, Open Test 2. I am from Aakash Invictus Institute. So let's start with the discussion. Let's get started now. See, the section 1 comprises of 4 questions. As you've all given the paper, it is a single correct section first. Okay, so in the first part C, we have 2 thin parallel plates. These are having charges. This is, I'm marking it as plate number 1. This is plate number 2. These charges are mentioned to us as 10 and minus 10. Now there is a thick metal slab. This is the slab. So since it's a metal, so we can say, and this is actually given a charge 20 microcoulomb. So this implies the total charge is going to be, basically it can be redistributed amongst the surfaces. Now see, the distances between the slabs are actually mentioned in the diagram. This is D, this is 2D, right? So if I say that the capacitance, the field which is going to be present over here is actually having capacitance C, then the other is going to have the capacitance C by 2. This is what we can write here. Now see, in this, it mentions that these plates are going to be earthed later on. So if they are going to get earthed, okay, we already know the initial charges on the plates and these are getting earthed. So earthing means that the potential, once these are closed, so this means that the potential at this position will turn out to be 0. Potential at the lowest plate is also going to turn out to 0. But since this becomes the isolated system, it is not connected to any wire, so its potential will be V. All right. Now, as soon as we close, there will be a redistribution of charges. Fine. I am assuming that charge on the upper plate over here is Q. Charge on the lower plate will be 20 minus Q. Okay. So equal and opposite charges are going to appear on the opposite faces. Okay, later on, once you are earthing this system. So see what happens, we have to find out the amount of charge that passes through the ground to the respective metal plates. Okay, so the main concern over here is to find out the amount of charge. So we are going to use this concept of delta Q. For each plate, we know the initial charge for each plate and we can find out the final charge. So I can write final charge minus the initial charge is going to tell you delta Q for each and every plate over here. Alright, so see, we already know the capacitance is here. So if you look at the potential difference, this is V minus 0 and over here also the potential difference is V minus 0. So we can consider them to be in the parallel arrangement or we can say the potential difference is same. Alright. So we can use this result, delta V, that is V minus 0, is equal to Q upon the capacitance, C by 2. And this is also equal to, for the other arrangement, 20 minus Q divided by C. So see, when we solve this equation, we are going to get, this is 3Q is equal to 20. So Q is turning out to be 20 by 3 microcoulomb. Right. So see, we already found out the charge on the upper plate of the isolated plate. Now when we talk about the first plate, so for the first plate, initial charge we already know it as minus 20 by 3. Okay, and final charge, initial charge was actually plus 10. This is what we already know. And final charge, we found this out as minus 20 by 3. Right. So we can find out delta Q for that as Q final minus Q initial, which is turning out to be minus 20 by 3 minus 10. Alright, this is minus 50 by 3 microcoulomb. Alright, this is for plate number 1. Now similarly, for plate 2, I can write delta Q as final charge minus the initial charge again. So see, the second plate had initial charge minus 10 and final charge as minus 20. This is minus of 20 minus Q, where Q was 20 by 3, minus the initial charge, that is minus 10. So this actually is going to give you, this is minus 40 by 3, all right, plus 10. Right, so we get the answer as D. Option D is correct for the first question. All right. Now let's move on to the second one. See, in the second question, it says that there is an electric field which is present. I can see this function is given to you, and this electric field is changing with the position, where R is given as the, see, R is the distance from the center of the circle, right? So by circle, we are actually saying that this is a circular region at a distance R. If I consider a small section here, this, right? So this section of length dr, its thickness, I'm considering this to be dr. All right. Now, isme dekho, we have been given the field is actually present normally. That means field is trying to enter into this plate. Okay, it's trying to enter into this plate. So that means flux can be found out by finding out the flux which is able to cross this region, right? The dotted part, because the field is actually a variable value over here. So I can write d phi is equal to E dr. Now dr is going to be the area, sorry, E dA. This dA is going to be the area of this shaded region. All right, so this turns out to be E times of 2 pi into R dr. This is what we have. We have the function over here. So we can write the net flux which is passing through it is E naught into 1 minus R by capital R. That was the value given to you. Along with this, 2 pi R is the region over here into dr. So we are integrating it from 0 to capital R. All right, so we can see this E naught 2 pi is coming out. So this is turning out to be R minus R square by capital R into dr, limiting from 0 to capital R. So this gives you a value of E naught into 2 pi into R square by 6. Okay, so the answer to this question turns out to be the first part. All right, so this was a simple question for flux. Now, the third question, it says there is I can see a ladder circuit over here. All right, so we have been given an ammeter and a voltmeter. Okay, and along with this there is a rheostat also. All right, so this is going to provide a variable resistance over here. Now we have to find out, okay, so if we are actually changing the resistance of this rheostat, we have to see what all values are being affected. Okay, the reading of voltmeter and ammeter. So see, I am going to consider, suppose this part has effective resistance R. So our circuit actually turns out to be like this. This is R, this R, and this complete circuit. I'm considering its resistance to be X ohms. Fine. So I can write this is in parallel combination. So this turns out to be Rx upon R plus X. Okay. Now along with this, we have a voltmeter attached and a circuit with a rheostat attached. And there is an ammeter, right? Now see, if I consider that I current is flowing through this branch, so I1 is going to be present here. It's dividing at this node. This is going to be I2. Since it's an ideal voltmeter as it mentions in the question, right? So this implies we can say there is no division of current here, only I2 current is flowing through this branch. All right. Now what if we increase the value of resistance? Okay, so if we are increasing the value of resistance, you can see I2 is going to decrease. Okay, so I2 decreases. I2 decreases means the reading of the ammeter is going to decrease. So the option where the reading of the ammeter is decreasing is this or this. All right. Now along with this, since I2 is decreasing and we know the potential difference measured by this voltmeter is actually the potential difference across this. Fine. So I can say if I2 is decreasing, then I1 is going to increase. I1 increases. So since I1 increases, we can say the potential difference across this voltmeter can be written as I1 into Rx upon R plus X. This is what we are getting. All right. So you can see the voltmeter reading will increase and the ammeter reading will decrease in this question. Okay, so the answer to this question is C. Option C is going to be correct. Fine. Now the next question. Okay. See, there are two concentric conducting spherical shells, S1 and S2 mentioned. Radii are given to you. अब इसमें radius के साथ साथ, हाँ, these values are given. There is a charge which is present at the center. Plus Q को center में रखा है, which is a point charge. Okay. Now see, the loss of energy when switch S is closed. So in order to find out the loss of energy, we are actually going to see this is U initial minus U final. So in the initial arrangement, we can say that this system would have the initial energy of this system would be, I can write this as, first of all, some self energy of each and every spherical arrangement, okay? And there will be some potential energy due to the arrangement of charges, due to the interaction of charges, all right? So I am going to consider, like this is the bigger sphere. Okay, so bigger sphere will have the same potential. See, there is this concept. If we have this bigger sphere, bigger shell, जिसका charge हमने ले लिया है suppose minus q, तो इसके हर point में जो field होगा, potential होगा, that is going to be constant. Okay, so at every point potential is going to be minus kq divided by the radius. इसका radius है 2r. ठीक है, so we are using the same concept. We are actually solving for the first one. पहले वाले के वजह से we are trying to find out the potential energies for this. Then the third, since there are three arrangements of charges, so there will be three interactions. Three interactions means this S1 is interacting with S1 and Q. Also, S1 is also interacting with Q, the charge at the center. Fine. So now, in order to find out the interaction potential energy, for the first arrangement, I can write, this is for the initial condition, all right, equation number 1. So for the interaction potential energy, for the outermost shell, I can write minus kq by 2r as the potential created throughout this region, and the charges which are present here are plus q, all right, plus. Now for the second shell, we can see kq by capital R would be the potential at all these points inside where plus q is kept, multiplied by the charge q. All right. So this is actually going to give you the value of, this is adding up together, right? So interaction potential energy, this is 2 and this is going to be 0. This is the interaction potential energy for the first part, right? Now we are going to solve for the final arrangement. Final arrangement means when the switch S is closed. Okay, see, this is the charge Q. Now there is one sphere here and the other sphere is like this, okay? Shell 1, shell 2. Now when we are connecting these two shells together, so see, this is an isolated charge, its charge is going to stay constant. And this conducting wire is making sure that the potential of position 1 and potential of position 2 becomes 0. This is what this conducting wire is actually used for. All right. So in this case, I am assuming the charge here to be Q2, Q1, and this is Q2. Fine. So see, when we had the initial arrangement, shell 1 had plus Q, shell 2 had minus Q. ठीक है? इन दोनों का जो sum of charges होगा, and यहाँ पे जो sum of charges होगा, that should balance. So this turns out to be plus Q minus Q is equal to Q1 plus Q2. So that means हमें ये तो पता चल गया Q1 plus Q2 is equal to 0. ठीक है? By conservation of charges for these two shells. ठीक है? Now, in order to find out the values of Q1 and Q2, अब हम potential at all these positions equate कर देंगे. ठीक है? So I'm just going to write the potential at 1 and potential at 2. Potential at 1 turns out to be, ठीक है? इसके वजह से इसके और इसके वजह से. This is K capital Q divided by R plus K Q1 divided by R on the surface of the shell plus Q2 के वजह से this is K Q2 divided by 2R. Now similarly, V2 is turning out to be, इस जगह पे potential is K into Q by 2R plus K into Q1 divided by 2R plus K into Q2 divided by 2R. Alright. When we are equating these values, V1 equal to V2. ठीक है? So we are going to get, see, जब हम इसको equate करेंगे, these values are common, cancel out हो जाएगा. ठीक है? Finally, we are going to get Q1 as minus Q. ठीक है? Charge that is appearing on this surface is minus Q. This is exactly opposite to the charge जो आपका initial moment में था. Alright. So this turns out to be, this implies Q2 की value आ गई capital Q के बराबर. So see in this arrangement, now we have this. यहाँ पे minus Q है, यहाँ पे plus Q है when we have connected और यहाँ पे Q है. ठीक है? Now see, again we are going to find out the same analysis here. We are going to use the same analysis. हमें ये पता है इन दोनों surfaces का, हमें again देखो यहाँ पे minus Q and previously plus Q. Self energy is not getting affected. तो V2 की value, I'll take it as U2. Final potential energy is equal to self energy remains the same. Okay. Plus we need to find out the potential energy अब इन दोनों की basically इनका interaction potential energy. So interaction potential energy will be, this is capital Q. So this turns out to be plus K into capital Q divided by 2R for the outermost shell. This is minus Q plus Q. Okay. Along with this, there will be a potential energy due to this arrangement also. This is turning out to be K into Q divided by Q upon R. Right. So this is, I can write for this arrangement, U final is equal to U self energy plus, this is turning out to be, ये तो 0 हो गया, so this is turning out to be minus K Q square by R. ठीक है? So now if we take the difference, देखो, initial हमारे पास जो energy आ रही थी, interaction was 0, but initial energy was only the self energy plus the interaction was 0. Finally हमारे पास जो value आ रही है, that is self plus this. So self energy में there is no change. We need to find out the self energy, the difference of energy, the energy lost. Delta U turns out to be U initial minus U final. That is KQ square by R, where K is 1 upon 4 pi epsilon naught. All right. So this is the answer for the second question. All right. Now, let's move on to part 3, which has more than one correct. Okay, so this question has a disk. External field is also given to you. Okay, now there is a particle which is fixed at R by 2. यहाँ पे हमने एक particle को fix कर दिया है, and that is a dipole actually. Dipole moment P is given to you. Okay, now fine. So this disk is set to rotate. That was the initial arrangement given to you. Alpha की value is given to you as pi by 3. ठीक? We have to find out the angle rotated for maximum angular speed. Okay. See, as we know that this arrangement is going to rotate because there will be a torque acting on the system. Okay. So we can say maximum kinetic energy is going to be when potential energy is minimum. Okay. So potential energy will be minimum when E and P are aligned in the same direction. Okay. So you can say E is towards x-axis. Now P is at an angle pi by 3. That means this complete arrangement, this was the initial arrangement, E, this is P, alpha. So it is supposed to reach this level. They have to be at the same angle. Okay, 0 degrees angle between them. So this implies angle rotated by the system for maximum angular speed has to be pi by 3 radians. Okay, because it mentions for the first time, for the first instant, it is supposed to be pi by 3 only. All right. Now we have to find out the maximum angular speed as well. ठीक है, तो इसके लिए we can just write initial potential energy plus initial kinetic energy is equal to final potential energy plus final kinetic energy. All right. So initial potential energy, as we can see, it is minus P into E into cos pi by 3. That is 1 by 2. Initial kinetic energy was nothing. The system was released. Now this is final potential energy will be minus P into E, cos 0 is 1. And final kinetic energy is half I omega square. This is rotating, right? So this is half of I into omega square. So we can write PE by 2 is equal to half of I into omega square, where P into E, I can be written as, this is rotating about the center of mass axis of the disk, okay, not the combined center. This is the fixed axis rotation, all right. So this turns out to be m r square by 2 plus m into r by 2 whole square into omega square, okay. So you can see this is turning out to be 4 in the denominator, so 4 PE upon 3 mr square is equal to the value of omega, right. So from this we can see this turns out to be option C. All right, this is the correct answer for question number 5. Now the next question. Okay, so this question has a concentric spherical shell arrangement, okay. It has a dielectric of constant K filled between them, okay. We have to find out the maximum charge, steady state current, all right. See, what I can see from this question is, आप ऐसे देखो, when we close this, एक तो इसका resistance turns out to be 2R, parallel combination, effective is 2R, all right. Now see, there is one more thing that I can see here in the question, that is, आपने जहाँ जहाँ से इसे connect किया, like if I talk about this, जितना current यहाँ से जाएगा, ठीक है, basically if you talk about this arrangement, I am considering इसका potential to be X suppose, okay. So this complete arrangement और यहाँ का potential मैंने मान लिया x1 के बराबर. So see, this point is going to be at x1. ये पूरा connecting wire is connected to the inner shell. तो इस पूरे arrangement के अंदर वाले part का potential हो जाएगा x1. Alright. Now if I consider the potential of this end to be 0, suppose, for my reference, I am considering it to be 0. Okay, so this gives you इस पूरे outermost region का जो potential है, that is turning out to be 0 के बराबर. So the charge, whatever charge is passing through this, okay, that charge is actually flowing यहाँ से इस तरह से radially outwards it is trying to flow, ठीक है. तो यहाँ charge ऐसे flow करने की कोशिश करेगा. So this actually means it will be experiencing some resistance because of the resistivity of the material, है ना. So what if we actually redraw this system as, we have this capacitor, जिसका capacitance we already know because it's a spherical capacitor, ठीक है, we already know the formula to this. Now this is 2R. Now see, ये वाला point, inner shell and the outer shell, ठीक है, इनके बीच में, so I can draw it as ऐसे, right? We can draw a resistor R which is actually in parallel to this capacitor over here, ठीक है. Because the thing is, हमने अभी देखा potential analysis, so we can actually see that the charge is moving out. So it is facing resistance through this spherical arrangement, ठीक है. Now we have to find out the maximum charge. So see, maximum charge का तो एक ही concept है यहाँ पे. We need to find out the potential difference between point 1 and point 2. और जब इसमें maximum charge store हो जा रहा है, तो उस case में we can actually see the current is going to flow. It is not going to flow through this branch. It is going to flow through this resistor ऐसे, ठीक है. I current यहाँ से flow कर रहा है. It's going to move around this. ऐसे यहाँ से I जाएगा and it's going to complete the circuit in this manner. Okay. Now using this, we already have the EMF here. Okay. Now I can find out. देखो ये this is a series combination of 2R. This is 2R, not 2 ohm. Okay, so this is 2R and this capital R are in series combination. Okay, so we can actually say for this arrangement R effective is turning out to be capital R plus 2R. All right. Along with this, basically we have this capacitor arrangement, the resistor, and there is, it was in the, sorry. Yes, it was in the opposite polarity. Okay, so we can actually see this turns out to be here, like this, and this is 2R. Okay, so in this arrangement, we can actually say, first of all, I can be written as E divided by R plus 2R. This is what we have. we have to find out the steady state current over here. Okay, so R, it's a spherical arrangement. Current is flowing in this manner. Radius is A. So for finding out the value of R, we can just assume a radius R, a shell of radius R, whose thickness is given as dr. Okay, so dr is turning out to be rho into dr, resistivity into length divided by area, that is 4 pi into r square. Now we are going to integrate this to get the value, integrating it from A to B. So this gives you a value of rho into B minus A upon 4 pi into AB. Okay, now similarly, since you have got this value, we can place it here to get the value of current, that is the steady state current. Okay, so I is turning out to be E divided by, that is rho into B minus A, okay, plus 2 times of R into, I'm going to write this as 4 pi A into B. Alright, and this is going to get multiplied over here. Fine. So this is a factor of 8, and this is what we are getting as the steady state current, right? Now similarly, we had to calculate one more thing. Okay, so we have, see, this is what we are getting for the first one. No, not this. We are getting the answer as 4 in the numerator. So that means we are getting this part as the result. Okay, now along with this, you can actually find out the value of maximum charge by finding out the potential difference across 1 and 2. Okay, so I can say potential difference across 1 minus potential difference across 2. The mod of this value is going to be I into R. Alright, so Q turns out to be C into potential difference, that is I into R here. I we already calculated, okay, we are just going to multiply it to C. Now for a capacitor, which is, it's a spherical capacitor, this turns out to be 4 pi epsilon naught upon into AB divided by B minus A. This is C multiplied to R that we have got and the resistance that we are getting. Okay, so we are going to get the result for this as B and steady state current as D. This is the answer for the 6th question. Now, let's move on to the next part. Okay, so this is a ring, a charged ring, a charge Q placed at the center. Fine. Now in this, these can freely move. Alright, so we have to find out the field at a distance x from the center, and this distance x is in the plane of the ring. Alright, so now see, if I consider this is the plane of the ring, now from the center I have to find out the field at any position which is at a distance x, right? So see, all these points are going to experience the field. It's a positively charged ring. So all these points are going to have a field in this manner towards the center, right? So I am going to take a Gaussian surface here. So the Gaussian surface is going to be somewhat like this. I'll just draw the Gaussian surface. Okay, so I am going to draw. We are talking about distances which are very close to the center. Keep this in mind. Okay, so I can actually write this as, see, now here, as we know, on the axis of the ring, field is away from it. I am considering this height to be y. From the center, this is also y. So field is also below. Okay, so above this ring on the axis, field is going to be away from it. It's a positive charge. And below it is, it's going to be away from it again. Okay. Now the field which is present over here in this region at a distance x, this distance is given as x. We can say there is no charge enclosed. Okay, so since there is no charge enclosed, so net flux should be equal to 0. Alright, so this actually can be found out. I am considering the field here as E1. Right, so since this is the field, so we get, for this arrangement, I can write E1 into, if you look at this, the area is turning out to be 2 pi x into 2y. 2 pi x into 2y, right? And for the regions which are above and below, so this is E into the area which is pi x square times 2. right? Because you can see E into area pi x square, E into area pi x square. Fine. So for the first one, these are going to balance out each other. All right. So we get E1 as, you can see 2 is getting cancelled. So E1 is turning out to be E by 2, right? So we already know for the axis, for the ring, on the axis at a distance y, we already know the formula of E, which is equal to 1 upon 4 pi epsilon naught, okay, into Q divided by this. If I consider this is y, and for a small y, we can always ignore the higher powers over here. So this turns out to be, since y is very, very less than capital R, all right, y is very, very less than capital R, so this implies we are actually getting the value as q into y divided by, I'll consider this as k only, k upon, this is turning out to be r cube. Fine. So E1, this implies E1, field on the plane is turning out to be half of this, that is q into y divided by 8 pi epsilon naught into r cube. This is going to be the field. This is going to be the field at position, at a point which is on the plane and very near to the center. All right. Now, we have to see if this charge q is displaced slightly. See, the masses of both the charge and the ring are given to be same. Okay. So, if we are displacing this charge slightly towards this direction, we are moving it by a distance x1. So we can be sure that the ring is also going to move in the opposite direction by some distance x2. Why we are sure about this? Because the center of mass is not going to experience any displacement over here, because there is no net force acting on the center of mass. All right. So we are going to use that concept over here. So let's see. I am going to consider this is getting displaced. It's coming here by a displacement x1 is the displacement. For this ring is going to move here by a distance x2. So see, net elongation in the spring is turning out to be x, which is equal to x1 plus x2. All right, this is what we have. Now, another thing is, since the charge is getting displaced, so see, this charge is going to experience a force due to the spring, that is k into x, and along with this there is going to be an electrostatic force which is q into E. We already found out the value of E, right? Okay, depending on the value, I considered this to be, we considered this distance to be x. Okay, so consider this value as x. This is x. Fine. So see, we considered this value. Now in this case, I can say the net force acting on the system, the net restoring force is going to be, F restoring is going to be, this is kx plus q into E. We already have the value of q into E. Okay. So this is because the displacement, we are talking about a position along the axis which is a distance x. Okay. So that is why the answer is going to be in terms of x only for the field. So this is q into, this is 1 upon 4 pi epsilon naught, okay, multiplied by, this value was x, 1 upon 4 pi epsilon naught, okay, multiplied by, this is turning out to be 8 in the denominator or 2 over here, right, into x upon r cube. Okay. This is the formula that we are getting over here. I am considering this to be x8. Yeah. Fine. Now see, x is the elongation in the spring, but we need to find out the time period of oscillation of this charge q. Okay. So we need to find out the value in terms of x1 over here. All right. So I can write acceleration over here is turning out to be k plus q upon 8 pi epsilon naught into r cube, okay, whole upon m into x. This is the elongation, but as we know, since center of mass is not displacing, delta x is equal to 0. So this implies m into x1 should be equal to m into x2. The reason behind this is, for the same reason, the net force acting on the center of mass is 0. Okay. So this is what we have. Therefore, we need to replace this x by x1. x is equal to x1 plus x2, that is 2 times of x1. This implies acceleration is turning out to be k plus q upon 8 pi epsilon naught r cube whole upon m into 2x1. Now this is omega square. Okay, if we compare it to the equation of SHM, this is omega square. So now we can write the time period as 2 pi by omega. Fine. We had to find out the time period. No, we had to find out the frequency of oscillation. It becomes even simpler, right? So we can just write it as frequency is equal to omega by 2 pi, right? So on solving this, on keeping this value of omega, we are going to get the result as this, okay? See, we are getting the similar result over here because this is when multiplied, okay? We are going to get the result of whatever we did here, okay? This is how we are actually going to solve this question. Next, let's move on to the next part. Now see, this is a numerical value question, right? In this section, we have a voltmeter. We have to find out the reading of the voltmeter. See, this section, this actually circuit seems like a reciprocal circuit. Okay? So if I1 current is flowing through this, यहाँ पे I1 जाएगा, okay? यहाँ I2 है, यहाँ I2 जाएगा. Right, so I am going to assign the potentials. I am going to assign this as V suppose. इसका potential मैं मान लेती हूँ 0 के बराबर, ठीक है? So now this point is having potential V minus V1. तो देखो इसके across potential difference is V1, तो ये वाला हो गया V1. Okay. Similarly, if I consider this to be V minus V2, तो इसके across potential difference is V2, तो यहाँ पे potential difference हो गया V2. ठीक है? Now, in this arrangement, see, in a node, whatever current is actually, basically whatever current is flowing through that node, the sigma of that, the total value of current flowing through that node will be equal to 0. So this gives you sigma I is equal to 0. So I'm going to write the current through each branch and add it to give you a 0 value. All right. That is the direction that I have assumed. तो ये value हो गई V minus V1 upon 5. All right. Plus, this is going to be V minus V2 minus of V minus V1 whole upon the resistance over here, that is 10, plus when we solve for this, this turns out to be V minus V1 whole upon 10. This sum is going to give you a 0 value. Okay. Now, on solving this, we can actually see the values over here. This is V2 minus. Okay, this is for the third one. V2 minus V minus V1. All right. These are the current through each branch. Fine. First branch, second branch, and the third branch. All right. So this gives you a value of V1 as V by 4. When you solve this equation, you get this value as V by 4. Now, we have to find out the potential difference across terminal 1 and terminal 2, right? So see, in this case, we have to find out delta V, that is the reading of the voltmeter. So ये जो reading होगी, that can be written as V minus V1 minus V1. है ना, ये इसका potential, V1 potential, take the difference. This is V minus 2 times of V1, which is going to give you V minus 2 times of V by 4, right, which is turning out to be V by 2, right. So V is this V, the value that I have taken is actually the potential difference across this. So this is turning out to be 11 by 2, right. So the answer to this question turns out to be this, 5.5, all right. Now, the next question, question number 9. So this question has, see, it is a cell, okay. We have to find out the total power dissipated in the given circuit All right, so we have to find out the value of n. All right, so we need to find out the effective value first, the total resistances. See, this is in series combination, 4 ohm. This is in series again. This is going to give you 8 ohm, right? So I can redraw this circuit. Fine, so this can be drawn as point A. This is 6 ohm. This is 12 volts. नीचे वाला हो जाएगा 4 ohm. This is going to be present like this. यहाँ पे 8 ohm आ रहा है. There is another resistor जो 8 ohm provide कर रहा है. These are in parallel combination. Connecting wires same potential provide करेंगे at all the positions. ठीक है? Now this 4 and this 4 are in parallel combination again. 4 ohm and there is another 4 ohm. ठीक है? So see, this is going to give you a 2. ये आपको दे देगा 4 ohm. Parallel combination. ठीक है? Now this 4 and this 4 are in series combination. ये 6 और ये 2 are in series combination. ठीक है? So this gives you a system as ये 12 volt आ गया. नीचे आ गया हमारे पास 4 plus 4 that is 8. ऊपर भी आ गया हमारे पास 8. This is going to be 8 ohms. ठीक है? So we can actually see in this arrangement R effective तो पता चल गया हमें, that is 4 ohm के बराबर. ठीक है? We have to find out the total power dissipated. ठीक है? So हम इसमें लिख सकते हैं V square by R कर सकते हैं, right? ठीक है? पावर की वैल्यू आ गई V square by R के बराबर because this complete system is in parallel combination. ठीक है? और V की वैल्यू is given to us, तो V की वैल्यू हमारे पास आ जा रही है, divided by R कर दो. ठीक है? So we get the answer as, अच्छा, now this value, keep this thing in mind, we have to find out the value of 3n. Equate it to 3n. तो इससे हमारे पास n का रिजल्ट आ जाएगा and the value of n would be 12 here. All right? Now, the next question. 10th. देखो, इस क्वेश्चन में आपको बोला गया है कि there is a volume charge density, rho is given to you. Fine. The charge density is independent of the values of x, y and z. Okay, that means y and, okay, so this density is depending only on x. Fine. And यहाँ पे this density is extending from minus infinity to plus infinity on y axis as well as z axis. ठीक है? So see, what I can think about this question is, अगर हमारे पास ये arrangement है, this is x axis, ये y axis है और बाहर वाली axis is z axis, right? So x equal to 0 to x equal to L, that is given to us. इस पूरे region में, this outside axis is z axis, इस पूरे region में we have a slab जो ऊपर भी infinity तक जा रहा है, नीचे भी it's extending to infinity. Similarly, out of the plane also it is extending from minus infinity to plus infinity. ठीक है? Into the plane and out of the plane. So in this region, हमें E की value variable दी है. So at a distance x, if we consider an element here, this, ये arrangement ले रही हूँ. ठीक है? Now if I see the side view of this arrangement, so I am going to consider an elemental part like this. ऐसा लेते हैं elemental part. ये वाला length हो गया dx के बराबर, the thickness of this arrangement. Okay? And इसका area I am considering this to be a के बराबर. Fine. We have to find out the value of electric field at L, 2L, 3L. Okay? That means anywhere on this side, ये जो आपके पास स्लैब का जो एक एंड वाला पॉइंट है, उस जगह पे कहीं पे भी आपको फील्ड की वैल्यू निकालनी है. ठीक है? बेसिकली बिकॉज फील्ड इज एक्चुअली going to have the same magnitude, it is going to be towards positive direction of x axis, क्योंकि y और z में it is extending from minus infinity to plus infinity. Okay? Now see, for this arrangement I can say positive charge हम मान रहे हैं इसको. ठीक है? So this is going to be away from the arrangement, electric field का direction. ठीक है? So I can write this as, इस जगह पे I can write the net flux through this can be written as E into the area जिसको ये कट करके जा रहा है, E times of A plus E times of A, because these are the field lines which are leaving this arrangement. ठीक है? Now this is going to be equal to integration of dq, the total charge which is enclosed within this region, divided by epsilon naught, right? So this is going to give you a value of E into 2a is equal to, ये हो जाएगा integral of rho is given to us, rho naught sine, this is pi x by L into इसका जो area होगा that is a, volume is a into dx, area is a and the length is dx upon epsilon naught, right? So see a तो cancel out हो जाएगा यहाँ से, so this is turning out to be E की value जो हमारे पास आ जा रही है, that is rho upon 2 epsilon naught, there will be pi by L here multiplied by sine का difference, integration is from 0 to, the limits are until L, okay? So ये value आपको मिल जाएगी minus cos pi into x, ठीक है? So this is going to be 1, right? So on solving this, when we place the values over here, see L is in centimeters, convert it 10 to the power minus 2 meters, right? ये micro में दिया हुआ है, ठीक है? Convert it to 10 to the, this is multiplied to 10 to the power minus 6. When you place all these values, you get the answer of electric field due to this arrangement as 36. Okay, on placing this value, this was the concept related to the question. Now, next is maximum power that can be dissipated in a resistance connected between A and B. ठीक है, A और B के बीच में आपको एक resistance connect करना है और हमें maximum power चाहिए. So for maximum power, we already know for P max, ठीक है, we know जितना भी internal resistance इस पूरे circuit का होगा, that must be equal to the external resistance जो आप A और B के across attach कर रहे हो, ठीक है? So I can do one thing, देखो I can see this as the parallel combination of cells, ठीक है? तो parallel combination का मतलब हो गया, ये value आ गई 6 ohms के बराबर, ठीक है? So E effective is turning out to be 6 by 6 plus 15 by 3 whole upon, this is going to be 1 by 6 plus 1 by 3, right? This is what we have. So ये value आपके पास आ जाएगी 1 plus 5, 6 divided by 1 by 2, that is 12 volts के बराबर, all right? So I can redraw this circuit as, यहाँ पे आ जाएगा 2 ohms, internal resistances, जो resistances in branches के हैं वो आ जाएगा आपके पास 2 ohms, इसके साथ we have a cell 12 volt और दूसरा एक और cell connected है 3. This is point B, this is point A, right? So this is what we have, ठीक है? This is what we have here. ये value आ गई यहाँ पे 3. Now देखो इन दोनों के लिए अगर हम बात करेंगे तो this is turning out to be 9, fine. तो हमें एक तरह से पता चल गया और internal ये जो net resistance across this branch है that is 4 ohms, ठीक है? तो यहाँ पे भी हमें जो resistor attach करना है for maximum power across AB, it has to be this thing 4 ohms के बराबर, all right? Now I can write current की value as, effective value was यहाँ पे 9 आ जाएगा, ठीक है? So this is E divided by इस पूरे का resistance that is 8. E by R is equal to I के बराबर, fine. Now power के लिए I can write power is equal to I square multiplied by AB का resistance that is 4, ठीक है? So this is going to be 9 by 8 whole square into 4, ठीक है? So the answer that we are getting after putting this value, we have to find out the value, maximum power. So the answer is turning out to be, in this question, 5.06, fine. Place the values so you can get the answer. Now the next question, question number 12, ठीक है? देखो इसमें बोला है a ring R, ring का radius R is given to us. It is lying in XY plane, all right? So I'll draw a ring. This is XY plane. ये X axis, ये Y axis. Fine. Now a charge has been spread uniformly. Okay, so see the charge density is given to you as lambda naught cos theta, right? So theta की value 0 से लेके pi by 2 तक. Between this region, charge is present. Since it's a cos function, so it is going to be positively charged. पाई से 3π/2, पाई से लेके 3π/2 तक cos is नेगेटिव, तो यहाँ पे आ जाएगा नेगेटिव. ऑलराइट, नाउ and for all the values of theta there are no charges. Second and fourth quadrant में there will be no charge. ठीक है. So now I am considering this to be at an angle theta with the horizontal axis. ठीक है. We have to find out the ratio of potentials. अच्छा देखो यहाँ पे ये दिया है R is very far away from in comparison, or we can say it's very large. Capital R is very large in comparison to the radius. हमें इन पोजिशंस पे बताना है, एक y एक्सिस में है, एक x एक्सिस में है. ठीक है, पोटेंशियल बताना है हमें. तो हम ये कंसेप्ट अप्लाई करेंगे. अगर हमारे पास एक स्मॉल डाइपोल होता है विच इज इंक्लाइंड एट सम एंगल थीटा, ठीक है, सो विथ सम एक्सिस फ्रॉम, बेसिकली दिस इज द लाइन जॉइनिंग द पॉइंट फ्रॉम द डाइपोल टू द पॉइंट वेयर वी आर सपोज टू कैलकुलेट द पोटेंशियल. ठीक है. So at this far away point, potential का जो result होता है that is kp cos theta by r square. We are going to apply the same concept here, क्योंकि हमें दिख रहा है we can actually form a dipole over here. Alright. So dipole के लिए if you see, यहाँ पे एक negative charge ले लिया और यहाँ पे I am considering a positive charge. ये plus dq हो गया. This is minus dq. Right. So this dipole has a length. dp की value will be equal to length इसका 2r multiplied by the charge. Charge की value हो जाएगी lambda multiplied by r d theta. This is lambda multiplied by r d theta. Right. So this is the value of dp. Alright. Now see in this arrangement we already know the value of dp now. और हमें जो points दिए हैं वो far away points यहाँ कहीं दिए हुए हैं. ठीक है. So we have to calculate the potential at r, 0, 0 and another point जो ऊपर की तरफ है 0, r, 0. At these points हमें potential निकालना है. So see, पहले मैं x axis वाले point की बात कर रही हूँ. ठीक है. So for the x axis वाला point, this is going to be, this dipole will have a dipole moment from negative charge to positive charge. So dipole is actually in this manner. ये आपके पास डाइपोल है dp and it is present from r, 0, 0 on x axis. It is going to be present at a distance. It is going to be present at a distance r. Alright. Now ये angle theta है. So see हमें dvx की value पता चल जाएगी. I'm finding out the value of vx over here. So dvx की value आ गई. This is dp into cos theta, ठीक है, divided by इनके बीच का separation is r square multiplied by k. So this is dvx, right? Similarly, अगर मैं y axis की बात करूँ, so this dipole dp from the y axis it is present at an angle 90 minus theta, right? So यहाँ पे cos theta के बदले we'll get a sin theta. This is the only difference that we are getting here. All right. So I can write dvx dvy is equal to k into dp into sin theta divided by r square, right? So we just need to integrate these values to get the ratio, right? So vx upon vy चाहिए हमें. So this is turning out to be integral of k dp by r square into cos theta. Now this is integral k dp sin theta upon r square, right? So अभी dp की value place करते हैं. This is vx by vy which is turning out to be, देखो dp की value was, we already wrote this here, 2r, ठीक है, this is 2 into small r, 2 into small r into lambda naught cos theta multiplied by small r d theta, because the radius over here is given as small r. Okay, so this is going to be small r. This is going to be smaller. Fine. So now this is what we have. This is the value of dp multiplied by cos theta divided by, see, k by r square is getting cancelled over here. So this is 2r into lambda naught cos theta into small r d theta multiplied by sin theta. So we just have to integrate. We are going to integrate this part. Vx by Vy. We already know the limits also, 0 से पाई तक, ठीक है. तो ये वैल्यू आ जा रही है इंटीग्रल ऑफ कॉस स्क्वायर थीटा डी थीटा 0 से पाई बाई 2 तक, ये मेंशन किया हुआ है. नीचे आ जा रहा है साइन थीटा कॉस थीटा 0 to pi by 2. Okay, so when we solve this result, 0 to pi by 2 has the basically the reason is, see the values are given to you 0 से pi by 2. So हम dipole consider कर रहे हैं, so we are already considering both the quadrants here, है ना. So this gives you a value of pi by 2, Vx by Vy. यही रेशियो हमें निकालना था. So this is the answer to question number 12. ये वैल्यू आ जाएगी. All right, now let's move on to the next question. This, देखो, figure shows a network consisting of infinite, again the ladder arrangement, ठीक है. आपको बोला गया है A and B are these points, ratio with which the charges of two successive, all right, इसका charge Q1, इसका charge Q2, इसका ratio बताना है. Q1 by Q2 is given as R. We have to find out this value over here. All right. Now see, this is an infinite ladder. If we consider this complete arrangement has the capacitance, suppose X, right? So across this arrangement also, we know that the capacitance effectively is going to be X, right? So ये दोनों तो parallel combination. I can draw this arrangement as, we have a 2 microfarad here. This is a 2 microfarad. इसके साथ we have another one which is, all right, so this is going to be 1 microfarad. ऐसे बना दे रहे हैं, ठीक है. See, ये पूरा x is in parallel to 1, so इसको लिखेंगे 1 plus x. Now this is in series, okay, and the series combination is going to give you the resultant, the effective value of capacitance as x. Fine. So I can write x is equal to, in series combination, this is going to be 2 into 1 plus x upon 2 plus 1 plus x. All right, so we get a quadratic equation. Using this quadratic equation, we will get the value of x as 1. Right, so this is 1 microfarad. ठीक है, तो इस पूरे x का value 1 microfarad पता चल गया. So now see, we can actually redraw this circuit again. ये पूरा है 2 microfarad. This is 1 microfarad, right? And the part which is lying to the right of this arrangement has net value as 1 microfarad. ये अभी हमें पता चला, ठीक है. So जितना charge यहाँ से जा रहा होगा, that is getting divided into 2 parts, right? ऐसे. This is Q1, this is Q1. It's getting divided into 2 equal parts because C की value same है, ठीक है. So I can write Q is equal to 2 times of Q1. So the ratio that you're getting over here, it's getting halved, right? ठीक है, तो ratio की value आ गई आधी, half हो जाएगी, ठीक है. So we have to find out the ratio. 1 और 2 में कितना part में divide हो रहा है? That is 1 by 2. All right. Next. So the answer is this, 0.5. All right. So now this question is a multi-choice. Fine. So this has 2 lists. It's a matrix match type of question. It has 2 lists. We are going to solve this now. We have to solve the parts over here. देखो, इसमें C1, C2 दिए हुए हैं. And I can see कि दोनों की वैल्यू बराबर दी हुई है. C1 and C2 both are equal to each other. ठीक है. Now battery is given. There is a resistor R also connected. Fine. And this capacitor might have been charged initially. पहला दिया है अगर हमने चार्ज नहीं किया. तो अगर हमने चार्ज नहीं किया है, V की वैल्यू 0 रखी है, तो चार्ज ऑन C2 in steady state हमें चाहिए. ठीक है. So for that arrangement, we can actually see it becomes a simple one, right? For the first one, I can say it is a capacitor C, another capacitor C. Steady state की बात कर रहे हैं तो no current is going to flow through 2R. So we might not as well make that actually. This is V0. इसका effective capacitance आ जाएगा C by 2. This is C effective. All right. So now I can say the charge इसमें जो आएगा in steady state, that is going to be C by 2 into V0 के बराबर. All right. So I can see that this first part is actually matching with the option number 2. Okay, now again we have to see V की value 0 ही रखिए, it is uncharged but the time is given to us, it's a transient circuit now, alright, किसी time पे हमें पूछा गया है, तो we'll just write the equation to this, ठीक है. So see, it's uncharged, so we can write for this arrangement, we have this capacitor C, this is C, ठीक है. Now there is a resistor also, so there will be current flowing through this resistor, potential was V0. So I can write tau is equal to, this is going to be C by 2 into 2R. Tau की value तो RC के बराबर आ गई, so I can apply the formula directly for the second part, ठीक है. Q is equal to Q0 1 minus e to the power minus t by RC, alright, and time is already given to us, RC ln 2. ठीक है, so this turns out to be C V0 by 2, we already calculated this, 1 minus e to the power minus RC ln 2 by RC, ठीक है. So ये value 1 by 2 आ जाएगी, so this turns out to be C V0 by 4. This is the charge which is present on the capacitor C2, ठीक है, when it is initially charged, uncharged, all right, potential was 0, V0 was 0, तो इसका जो आंसर है that matches with the part 1, right. Next, V की value V by 4 पे आपको C2 पे चार्ज दिखाना है, ठीक है. So we are going to do the same thing here. अब देखो यहाँ पे क्या है, अब difference क्या है, we have this arrangement, this already has a charge plus, यहाँ पे minus charge है, ठीक है, right, plus minus are shown to you, ठीक है. इसके साथ we have to see, इसका already charge present है, जो Q0 हमारे पास आ रहा है यहाँ पे, initial charge that is C V0 by 4, ठीक है. तो ये हो गया C V0 by 4 already है. Now if we are connecting it to a system, a cell जो 2R charge carry, 2R resistance present है जिसमें, I am considering जो charge यहाँ पे flow कर रहा है वो Q के बराबर. So this becomes, later on I am going to write this as, देखो इसका चार्ज मैं मान लेती हूँ प्लस Q, ये माइनस हो जाएगा, और इस वाले में this is the extra charge which is flowing through the battery, ठीक है, which is given by the battery basically. So I can write, ये था V0 के बराबर, तो हमारे पास इक्वेशन आ जाएगी V0 minus Q by C, ठीक है, and this is minus of C V0 by 4 plus Q divided by C minus I into R, ठीक है. So I की value I can write this as dq by dt into 2R, यही आ जाएगा, I into R, ठीक है. I've sent it to the opposite side, तो ये value आ गई हमारे पास, है ना. So this is going to give you, ये C V0 यहाँ पे आ जाएगा, if I take the LCM over here, ठीक है, तो this is turning out to be 3 V0 by 4 into C, ठीक है. ये वैल्यू आ गई आपके पास माइनस ऑफ 2 टाइम्स ऑफ Q बाई C इज इक्वल टू, आई एम टेकिंग द एलसीएम सो आई माइट एज वेल रिमूव दिस C, ठीक है. सो दिस टर्न्स आउट टू बी 2RC इंटू dq by dt, alright. So this is the equation that we are getting, fine. So हमारे पास इस इक्वेशन से if I divide this by 2, तो हमारे पास आ जा रहा है 3/8 V0 into C minus Q is equal to RC into dq by dt, ठीक है. So when we solve this equation we get dq divided by 3/8 C V0 minus Q, and this is turning out to be dt divided by RC, fine. So on solving this equation हमें Q की वैल्यू पता चल जाएगी यहाँ से, ठीक है. आपको टाइम की वैल्यू दी हुई है, दिस इज 0 फ्रॉम, अभी हम we'll find out the value for this, ठीक है, जो भी टाइम के टर्म्स में है, दिस इज 0 to Q के बराबर, राइट. सो दिस टर्न्स आउट टू बी, Q की वैल्यू आपके पास आ जाएगी यहाँ से, दिस इज 3C V0 by 8 multiplied by 1 minus e to the power minus t by RC, okay. This is the value of Q, ठीक है. सो यू हैव इजीली फाउंड आउट, ये जो आपके पास वैल्यू आ रही है, दिस इज व्हाट वी हैव ओवर हियर, ठीक है. नाउ फ्रॉम दिस अब हमें चार्ज बताना है, ठीक है, ये हमने एज अ फंक्शन निकाल दिया है. Now we can put the value of t. Steady state में ये जो चार्ज की वैल्यू आ जाएगी आपके पास, ठीक है, ये मैक्सिमम वैल्यू जितनी होगी, ठीक है, वो पता चल गया हमें. नाउ सिंस हमें बताना है चार्ज ऑन दिस कैपेसिटर सी, इस वाले में फाइनल चार्ज बताना है. सो आई कैन राइट फाइनल चार्ज ऑन दिस कैपेसिटर. देखो इनिशियली चार्ज इसके पास सी वी नॉट बाई 4 था, सी वी नॉट बाई 4, और फाइनली जो आपने चार्ज निकाला है वो इसमें ऐड हो जा रहा है, ठीक है. सो दिस इज गोइंग टू गिव यू द फाइनल चार्ज ऑन द कैपेसिटर C2. सो फाइनली वी गेट द रिजल्ट आफ्टर सॉल्विंग दैट इक्वेशन एज D. ऑप्शन D इज गोइंग टू बी द करेक्ट आंसर, ठीक है. दैट मीन्स इसकी जो वैल्यू आती है दैट टर्न्स आउट टू बी ये, ठीक है. नाउ V नॉट बाई 4 का जो स्टेडी स्टेट का चार्ज आ रहा है दैट इज टर्निंग आउट टू बी 3V नॉट बाई 5V नॉट बाई 8, ठीक है. वी आर जस्ट एडिंग दैट टुगेदर, ठीक है. ऑल राइट, नेक्स्ट क्वेश्चन नंबर 15. फाइन. सी इन दिस क्वेश्चन हमें यहाँ पे अगेन स्फेरिकल कंसेंट्रिक शेल्स दिए हुए हैं, ठीक है. अच्छा ओके, सी स्फेरिकल कंसेंट्रिक शेल मतलब हमारे पास एक ये है, दूसरा ये वैल्यू है. दिस इज A, दिस इज B, ठीक है. नाउ टर्मिनल्स ऑफ द बैटरी आर कनेक्टेड टू द आउटर शेल. पहले पार्ट को देखेंगे. अगर हमने इसमें फर्स्ट पार्ट में आउटर शेल पे वी हैव अटैच्ड अ टर्मिनल. टर्मिनल अटैच करने का मतलब बस यही है दैट हियर वी आर एक्चुअली गोइंग टू सी this point, this complete shell is going to be present at the potential V, right? So see, when this is at V, so the potential over here is going to be same. That means electric field within this region is going to be 0. And the next at infinity, r equal to infinity, we consider the potential to be 0. So that means the field is going to be present between the outer shell and the region at infinity, right? So this gives you a single shell, a single capacitor. The capacitance of this shell will be 4 pi epsilon naught into B, right? Because the thing is, the shell, the outer shell is only connected to the positive terminal. So electric field, capacitor has the tendency to store energy in the form of electric field energy, all right? So this is the region. So this becomes the answer for the first one, all right? Now, terminal of the battery is connected to the inner shell, and the other terminal along with the outer shell is grounded, right? So that means if we have this terminal of the inner shell, this is connected to V, right? That means the potential here turns out to be V. This is only what it means by the question, right? This is what it exactly means. So now the other shell along with the next terminal is grounded, right? Outer shell is grounded, fine. Okay, so that means potential here turns out to be 0. Sorry. Yeah, potential here is 0 and potential at r equal to infinity is also 0, right? That means the field is going to be present only in this region, right? E is not equal to 0. It is like it is unlike this case, right? So here we can say that the capacitance turns out to be 4 pi epsilon naught. The field is present between this region, whatever the field is, right? So this is give you 4 pi epsilon naught into B by A upon B minus A as the result for the second part. Okay? Now third one dekhte hain. Third is positive terminal of the battery. Sorry. Positive terminal of the battery is connected to the inner shell and the negative terminal is grounded. All right. Inner shell ka positive hai, negative ka negative grounded hai. So that means for the C part, the third part, this is connected to the positive terminal. That means is pure ka potential we have considered it to be V. Now the other terminal is grounded, right? That means whatever charge is appearing on it, it is going to be induced on the other shell also. So the field is going to be present within this region. Okay, E is going to be present and from the outer shell to R equal to infinity also. So this actually gives you the effective capacitance as 4 pi epsilon naught multiplied by the region between infinity and the radius A. Alright, this is going to be the result. Now similarly for the fourth one, See, fourth one is positive terminal is connected to the outer shell and the inner shell is grounded. All right. So see, now we have two arrangements over here. Okay. Just focus on this part. In this arrangement, inner shell, outer shell. This has been grounded. That means potential is 0. And R equal to infinity also is going to be the region where potential is 0. But the battery is going to give you the potential on this surface as V. That means electric field is going to be present between this region and from the shell to infinity. There are two capacitors over here, C1 and C2. Both are in parallel combination. So C effective for the fourth part turns out to be C1 plus C2. C1 is between this, which is turning out to be 4 pi epsilon naught into BA divided by B minus A, plus C2 is between the outermost shell and infinity. So that is turning out to be 4 pi epsilon naught into B. All right. So see, by solving this, I can see we are getting 4 pi epsilon naught into B square divided by B minus A. The A terms are getting cancelled. So the final answer for this question is going to be this. All right, B part. Now we are going to move on to the next question. 16th, the last question of paper number 1. All right. Now see, this question is asking us to find out. It's an RC circuit. Tau is the time constant. Okay. So it's a similar pattern basically. We have to find out the steady state charge on each capacitor here. Okay. So I will be starting with the first one first. The concept is same. For all the parts, we are going to follow the same steps. So for the first one, see, we have this E. I am going to find out the value of tau first. Okay. I am focusing on tau right now. So for tau, this is R effective into C effective. Okay. So for finding out the tau, we can always short the battery, okay, and find out the effective capacitance across the terminals of the capacitor. This is 4R. The other one is 2R. All right. Now this is 2R. After shorting the battery, this is what we have here. Sorry. These are the terminals for which we are focusing on. This is X, this is Y. Okay. So see, this is in parallel combination. Okay. So this is going to give you 4R times 2R divided by 6R. That is 8 by R, 8 by 6R. And this is R. So see, we are getting R effective in this part as 2R plus 4R by 3, which is going to give you 10R by 3. Okay. C is only one capacitor is present, so tau turns out to be 10 RC by 3. That means this matches with the fourth part. All right. Now, in order to find out the steady state charge over here, I want to find out the potential difference across terminal 1 and terminal 2. Because see, when it is completely charged, it is not going to accept any charge any further, right? So now, for this arrangement, I can say, we have, this was 4R, this is E, the other one is 2R. I want to find out the potential difference across this terminal. I can write I is equal to, this is going to give you E divided by the total resistance, that is 6R. So potential difference across 1, 2 terminals, this is going to give you I into 4R. All right, which turns out to be E by 6R into 4R. All right, which gives you the value as 2CE by 3. All right, in the same pattern, we are going to find out the value for the other parts also. Now see, for tau, we are going to short this battery. Okay, if we are shorting this, we can say these two are in parallel combination. All right, so I can write for the Q part, we can see this 4 and 4 are in parallel combination. I might as well draw it as 2R. All right. Now there is one resistor R over here. This is R. Okay, and this is 3R. Fine. So this is 3R and the capacitor ends are, these are the points where the capacitor is connected, right? So see, 3R and the remaining part is also giving you 3R. So I can see from this arrangement, this 3R and this 3R are in parallel combination. So R effective is turning out to be 3R by 2, parallel combination. So tau is turning out to be 3R by 2 multiplied by C. Okay, 3R by 2 multiplied by C, which means this matches with the first part over here. All right. Now similarly, for finding out the charge, we can actually select these 2 points like point 1 and point 2. Okay, if you see, this point and this point are going to tell you the potential difference which is across this capacitor, whatever current is flowing through the circuit. Okay, it won't be affecting the capacitor because capacitor is not allowing any current to pass through it because it is fully charged. Okay, so we want to find out the potential difference delta V across this capacitor. So for this, we can actually solve the circuit as this was the arrangement. This is E 4R. I'll just redraw the circuit. This is 4R. This is 4R again. Okay, and now there is a 3R resistor here, 1R here, and I am interested in terminal 1 and 2 only. Okay, so delta V, you can see whatever current is flowing through this, it's getting divided into exactly 2 parts. If I is flowing through it, so it's getting divided into I by 2 and I by 2, again for the same reason. There is no current passing through this. Okay, so this turns out to be the arrangement. All right, so I can write delta V is equal to I by 2 multiplied by the resistance 3R. So the steady state charge Q turns out to be C into I by 2 into 3R. Alright, now this I by 2 can be found out using Kirchhoff's laws over here. So this can be written as E minus I by 2 into 4R. This is E equal to I by 2 into 4R. And across this resistor which is I into 4R. Alright, so on solving this, you get the value as 1. Okay. See, first of all, even if in this question, if you just find out the value of tau, you'll get the answer because there are no quantities which are matching. Okay. Now, let's solve for the other part also. Now again, we'll calculate the value of tau. So we are supposed to short this circuit. So for shorting this circuit, we can actually see this 2R is in parallel with the other 2R. Okay. So this is R and R above the capacitor and 2R below the capacitor, right? So for the R part, I can say the part R, 3R is above the capacitor and 2R is below the capacitor. Okay, this is 2R. Fine, so tau turns out to be, it's in parallel combination, right? So this is going to be 6 divided by 5 R into C. When you take the value of R effective, okay. So this is going to match with this part, all right. Now, again, for finding out the value of charge, I must find out the potential difference across this branch, all right. So for that, I'll draw the circuit over here. So in this, whatever current is flowing, okay, so I can actually redraw this circuit as, we have this cell. Okay, this is the arrangement here. I am interested in this point. This is 2R. No, this is, yes, this is turning out to be 2R. So this is going to be 2R. Capacitor is between these two ends. Okay, so now this is 2R, this is 2R, fine, and this is what we have. Now whatever current is flowing through this, it's getting divided into 2 parts again. So I1 and I2. So see, this is 2R. We can write according to the same potential difference across this arrangement and the 4R. I can write I2 is equal to, or 2 times of I2 is equal to I1 according to the potential difference. Now since we already calculated the value of I2, so I can write the potential difference across this arrangement is turning out to be, this is I2 multiplied by 2R. All right, this is the potential difference. Using this, we can find out the value of C, which is turning out to be C multiplied. We have to find out the value of tau. Sorry, charge. So charge is turning out to be C multiplied by I2 into 2R. Right? So this is how we are going to find out the steady state charge in this arrangement. So this value matches with C by 5 on solving it. All right. Now, similarly for the third part, last part, S part, I want to find out tau. So for tau again, we are going to short this arrangement. So see, on shorting this arrangement, I can see this 2R and this 2R are in parallel combination. I can actually redraw this circuit as this is 3R. Now there is a capacitor C. There is a resistor R again over here. I'll mark it as 2R. Okay. Now on marking it as 2R, here we have R and these two resistors are connected to the same point. So I can draw this as 2R and 2R like this in this arrangement. Fine. Now this is 2R, this is 2R. All right. This is giving you R and this is R. So see, this 2R and 2R are in parallel combination. So 2 plus this is going to give you basically a value of R, 2R and 2R. Okay. Now 3R and R. So R effective here is turning out to be 4R. So tau turns out to be 4R into C. All right. So 4R into C, that means the third part. Right. Now, in order to find out the steady state charge, these are the 2 points where you are going to find out the potential difference, because the thing is, this is the branch which is not going to accept any current, all right, or any charge, because the capacitor is fully charged, all right. On solving this, we finally get the answer as, you can see, A. This is the final answer to the 16th question, all right. So this is the end of paper number 1. We'll be meeting soon in the second session also, all right. So thank you everyone. I would like to invite Vipul Duggal sir for discussing chemistry with us. Okay. Hello sir, how are you doing?
I'm fine. Thank you for the thing. It was a wonderful session.
Yes.
So how was the physics paper 1?
It was actually of moderate difficulty. Paper 1 was of moderate difficulty.
Okay.
Okay. And basically if the students are actually getting 60% of the total score, all right, in physics particularly, then it will be considered as a good score.
Okay, that's good. Thank you. Thank you, ma'am.
Thank you, sir.
Hello, everyone. I'm here to discuss the chemistry paper of JEE Advanced, Open Test 2. Let's make the session informative, and I know you all will be eagerly waiting for the answer key. So my name is Vipul Duggal, chemistry faculty at Aakash Invictus. So let's begin the session. So this is a section 1. It has 4 single correct questions. Let's start. So very first question is here, the paraxylene is reacting with cyclic anhydride having a chiral center. This sequence of reaction, sequence of reagent is given to you. So let's start the question. So you must know the structure of xylene, paraxylene, and you will have to recognize you will have to think about what can be the cyclic anhydride here that will have a chiral center. So here cyclic anhydride is having 5 carbon atoms. So 5 carbon atoms के साथ एक chiral center तो हो नहीं सकता है. There cannot be one chiral center with the 5 carbon atoms, and there cannot be 3-membered cyclic anhydride. So it would be like 4-membered cyclic anhydride. So let's make the structures. This is the paraxylene, and the cyclic anhydride would be of 4-membered ring and having chiral center. There is 5 carbon atoms in the cyclic anhydride, and it is reacting with the AlCl3 followed by the addition of water, hydrolysis, and it will be a mechanism used here will be electrophilic aromatic substitution. So what can we think about? We all know that This is a very common reaction we study in the classrooms. Either this oxygen will interact with this AlCl3 or this oxygen will interact with this AlCl3. And the attack will be from the ortho positions, this ortho position or this ortho position. Okay. So we will get two products here. Product P and product Q. One is forming in 70%, other one is 30%, one is major and one is minor. So what can be the products? Let's draw. These are the products. When ortho position will be attacked here, so this will be a product. So this can be a P and Q. इनमें से कोई एक P है कोई Q है. We know that here the carbocation will be sterically hindered. Here it is not sterically hindered. So it will be formed in a major amount. So this can be a product P. Product P would be this and product Q would be this. After that, P is reacting with the ZnHg, concentrated HCl, and Q is also reacting with the same reagent further reacting in both the cases. So this is Q, this is in 30% and this is in 70%. So when it is reacting with the ZnHg concentrated HCl, we know that it is a Clemmensen reduction. So it will reduce CO group into the CH2. Thus this will be a next product. Again from the P, we are using the Clemmensen reduction. This will be a product forming from Q. Okay. Now what are the next reagents? H plus heat dehydration followed by the Clemmensen reduction again. Here again dehydration followed by the Clemmensen reduction. So what will happen here in case of this, the product forming from the P is R and product forming from the Q is S. So here the OH will interact with the H plus and will be removed as a water. And again the electrophilic aromatic substitution will take place. From this position, this will be attacking here. And also we have done the Clemmensen reduction. After that, this CO group will be reduced into the CH2 group. What will be the final product? There will be a 6-membered ring formation. You can clearly see. And 1, 2, 3, 4, 1, 2, 3, 4. At the fourth position, there is a CH3 group present. Just like same in the case of S, is reacting with the same reagent here. So H plus will be interacted with this OH and will be removing as a water molecule. And there will be a electrophilic aromatic substitution again after the formation of carbocation here. And followed by the Clemmensen reduction, this CO group will be reduced to CH2 group. And there will be a final product with 6-membered ring formation like this. And what are the position of the CH3 group? 1, 2, 3 at the third carbon. Let's see the question again. product forming from the final product forming from the P is T, and from the Q is U. So this is U and this is T. Okay? We can clearly see that U and T are same compounds. Or this is a single correct question and we can clearly see T and U are the same compounds. This we got. But we should also check the other option as well for the safer side. M1 reaction with LiLH4 gives optically inactive diol. Let's see. Where is M? If it is reacting with the LiLH4, both the anhydride group will be converted into the alcohol. And the product would be like this. And this is the chiral center. And this is optical inactive, optical active product. So this option is incorrect. Again asking about P. P is having one alpha hydrogen adjacent to ketone. Where is P? And we P. Here alpha hydrogen, two alpha hydrogens are there. Again, it is incorrect option. Degree of unsaturation of R and T is different. Where is R and T? Here is R. Degree of unsaturation is ring के कितने degree of unsaturation हो गए 4 and this is 1 5. Where is T? 4 and ring 5. So degree of unsaturation in case of R and T is same. Incorrect option. Let's check the answer. So answer B is given. Okay. Let's move on to the next question. Which of the following statement is correct regarding nucleophilic substitution reaction? It is asking about SN2 and SN1 reaction. तो very basic question, but देखते हैं कि reactants कैसे है. तो हमने देखा कि इसके अंदर 4 different reactants are given in the reaction. Every case में 4 different reactants हमें given है. तो let's talk about the SN2 first. Okay? तो SN2 के अंदर more sterically hindrant reactant का rate जो होगा सबसे कम होगा और जो less sterically hindrant होगा उसका rate faster होगा. And SN1 के अंदर we see the stability of carbocation. Let's see. In option A, this should be the least reactive. Okay? And this should be a most reactive. But what about these two? What about these two? So this is a primary alkyl halide, this is a secondary alkyl halide. And primary alkyl halides have more reactivity towards SN2 reaction. So incorrect option. What about SN2? Let's check the answer. Option C. Again, this should be a most reactive. This is incorrect. In this way, you can eliminate the options. You should. And what about B and D? Talking about the SN1 reaction. In SN1 reaction, this should be a more reactive. Oh, in both cases, this is more reactive. It will give a stable carbocation having 9 alpha hydrogen. Okay. And this should be a least reactive. This should be a least reactive for the SN1. This is a primary. Okay. But what about these two? This is a secondary. This would be a more reactive than this. How will you decide between these two? How will you decide between these two? Both are primary alkyl halide. If you are thinking like that, it will generate a carbocation having 1 alpha hydrogen and it will generate a carbocation having 2 alpha hydrogen, you would say कि sir ये वाला ज़्यादा reactive होगा, ये वाला ज़्यादा reactive होगा. But thing is not like that, because in both the cases SN1 reaction is not preferable because both are the primary alkyl halides. So what you have to do here, like a neopentyl rearrangement that you already often study in the classroom. So here we can think like this. At the same time, if the hydride is shifting here and the migration of leaving group takes place simultaneously, with the same case we can think like this. I know this is a very difficult process, but if the SN1 has to be happen here, it would be like this. So here we will get a stable carbocation. Here we will get a less stable carbocation. So it would be more reactive than this reactant. So option D should be correct. Let's check the answer. What is the answer given? Yes, option D is correct. Please check your answers. Okay, let's move on to the next question. Very basic question. It was on SN1 and SN2, but the basic was asked in this question. Oh, next question, question number 19. There is a lot of reagent given in this reaction. You have to be careful in this reaction. So, very first reactant is here propanol. Propanol is reacting with PCC. You know that what PCC will do. It is a mild reducing agent, mild oxidizing agent. It will oxidize the primary alcohol, mild oxidizing agent, followed by the aldol condensation. But heating is not mentioned. The aldol addition will be there. Then again PCC is used. Then NH3 is used. Let's see what happens here. So we have been given that propanol is given and PCC is used. It is a mild oxidizing agent converting primary alcohol into the aldehyde. After that, aldol addition, aqueous NaOH is used. It will use two molecules, and simply you can do the aldol addition here. अल्फा हाइड्रोजन, एल्डिहाइड्स के अंदर अल्फा हाइड्रोजन है, एक्वस NaOH की प्रेजेंस में aldol addition हो जाएगा. तो आई एम मेकिंग अ प्रोडक्ट डायरेक्टली हेयर. यू कैन इजिली मेक. तो व्हाट कैन बी द प्रोडक्ट? Okay, this is the product. Now, what is the next reagent? Again PCC is used. Again PCC is used here. So what PCC will do? But aldol addition is there. Aldol addition is there. There will be a formation of beta hydroxy carbonyl compound. Beta hydroxy. So here it will be a OH group. After using the PCC, I've used the PCC along with that. After using the PCC, this secondary alcohol will be oxidized into ketone. And this is the product after using the PCC. What is the final reagent? NH3 is used. What NH3 will do? We all know that pH is set to be a 4.5 to 4.5 to 6. Again nucleophilic addition will take place with the ketone groups and amine formation will take place. Amine formation will take place here. So students, the formula of the final product has been given. C6H12N2. Okay, you can match. This is the N, product N. What is asking next? On hydrolysis, N gives T. On hydrolysis, N gives T. What will happen on the hydrolysis? So it will get hydrolyzed and again it will get converted into ketone. Okay, this is the product T. Let's check the options. What is asking? This is the intermediate product of reaction M2N. Reaction M2N. क्या हमारा ये intermediate product आया था बताइए? Yes, this was the intermediate product. But question is asking about incorrect option. See carefully. So this option is incorrect according to the question. T can give 2,4-DNP test. 2,4-DNP test. Yes, T can give. There is a presence of aldehyde and ketone group. Again, this is incorrect according to the question. Stereoisomers possible for NH6. Stereoisomers possible for NH6. Yes. Let's check the stereoisomers. This is a chiral center. Here About this double bond, geometrical isomers can exist. About this double bond, geometrical isomers can exist. And molecule is unsymmetrical. So stereoisomers would be 2 raised to power 3, 8. Okay. This is an incorrect option. This option should be correct here, according to the question asking. And the reduction of compound T, let's check the last option. Reduction of compound T with the ZnHg concentrated HCl produce 2-methylpentane. Okay. Reduction करना है इसका, Clemmensen reduction. These two group will be reduced into CH2 group, and you would get 2-methylpentane. Again, this is incorrect. So choose an incorrect option. Stereoisomers possible for NH6. Let's check the answer. Option C is given. Check your answers. Let's move on to the next question. Again, this is a single correct question. We have 4 single correct questions in section 1. Last question of single correct. A reactant you can clearly see. Reagent you can clearly see on the screen. Formaldehyde in the presence of NaOH. Formaldehyde is given in excess. First thought आपके दिमाग में क्या आया होगा? Aldol condensation का, because there is alpha hydrogen present here. Aldol reaction will take place between HCHO and this reactant given. And after that there will not be any alpha hydrogen, but HCHO is in excess. The Cannizzaro reaction will take place. Okay, let's make the product. Here I am doing the this reaction. See carefully. What will happen first when it is reacting with the HCHO? Here it will be a formation of carbon ion, and carbon ion का आपने अटैक कराया होगा formaldehyde के कार्बन पे, and aldol condensation कराया होगा. And this HCHO group would get attached here in the form of CH2OH like this. Very simple. Now we have a HCHO is in excess in the presence of OH minus. What will happen? Cannizzaro reaction will take place. There is no alpha hydrogen in both the reactants. In Cannizzaro reaction, we know that how the reaction proceeds. Cannizzaro OH minus would attack here. So this molecule would get converted into salt, HCONA, and this hydride transfer जब यहाँ से यहाँ होगा, this molecule का ketone किस में convert हो जाएगा? Alcohol के अंदर. So what we would get here finally, let me draw. This is the product after using this reagent. Along with that, there is a formation of salt as well, HCONA. What is next reagent? Formaldehyde in the presence of catalytic amount of H+. जैसे ही आपके दिमाग में ये आया होगा और आपने इसको देखा होगा प्रोडक्ट को, this is a diol and reacting with the HCHO. Let me draw here the final product. And two methyl groups are present here. Okay, this is the final product. Acetal, this is the product Q. An aromatic product, major organic product. Choose the correct options. Let's see. Compound Q has hemiacetal linkage. Incorrect. Clearly we can see compound Q has acetal linkage. Compound Q has 2 chiral center. बच्चों यहाँ पे कितने chiral center है? एक ही chiral center है. Again this is incorrect. This is the intermediate product of reaction P2Q. This is the intermediate product. Yes, we have formed this after doing the Cannizzaro. This is the product. Okay. Let's check for safer side. You should have checked all the options. Compound Q gives positive tolerance test. Obviously, this cannot give positive tolerance test because it is a acetal part. It has acetal linkage in this compound. Incorrect. Let's check the answer. Option C is correct. Let's move on to the next section. So section 2 is here. It has 3 questions. All of them are one or more than one correct. So very first question, question number 21 of section 2. Chloroform is reacting with the O2 and producing P followed by the reaction with the T giving Et2CO3 डाइथाइल कार्बोनेट. ऐसे लग रहा है इसको देख के कि दिस इज द इनऑर्गेनिक प्रोडक्ट लाइक, बट दिस इज द ऑर्गेनिक प्रोडक्ट. तो वेरी बेसिक रिएक्शन. आप सोच सकते थे स्टार्टिंग नहीं करते तो फिर हमारा क्वेश्चन नहीं बनेगा ये वाला. CHCl3 क्लोरोफॉर्म जब ऑक्सीजन से रिएक्ट करेगा तो क्या बनेगा? फॉस्जीन. द प्रोडक्ट P would be phosgene gas. And P on reaction with the T. P on reaction with T forming diethyl carbonate. This is the structure of diethyl carbonate. You should draw this structure. Now you can think about the what can be the T. Obviously T would be here. You know that this is the phosgene gas, very poisonous gas. We store it into the ethanol solution. And this product is a non-poisonous. So what can be the T? Ethanol. And what mechanism would be used here to convert phosgene gas into the diethyl carbonate? What mechanism? Tell me. It will be nucleophilic acyl substitution. 2 moles of C2H5OH will be used here. And the formation of this will take place. You can simply do this mechanism. Like this, nucleophilic acyl substitution. Again the next molecule will be attacked. Other Cl will be removed. Okay. Now we have predicted the T product reagent T here. Again T is reacting with NaOCl followed by the acidification. What is the NaOCl? क्लोरोफॉर्म का reagent. और हमें उसी टाइम देख के पता लग गया होगा कि C2H5T है और उसका क्लोरोफॉर्म रिएक्शन हो रहा है तो क्या होगा? First it will get oxidized into aldehyde because it can also behave as a mild oxidizing agent. So what will happen? C2H5OH, that is the product T, reagent T, you can say NaOCl followed by the acidification. First it would get converted into aldehyde, and aldehyde can give CH3CO group is present there, and aldehyde can give positive tolerance test. Okay, so it would convert it into CHCl3 plus sodium salt of methanoic acid. Okay, QNR. Now what is QNR among these? We can recognize easily from the next part. R is reacting with NaOH along with the phenol. तो आप सिंपली प्रेडिक्ट कर सकते थे कि R क्या होगा इसमें से. समझ आ रहा है कि यार फिनॉल की रिएक्शन के बारे में सोचना इन द प्रेजेंस ऑफ NaOH followed by the acidification, very common reaction. Tell me, what is this reaction? It is Riemann-Tiemann reaction, RTR. So this would be R and this would be Q. NaOH, phenol, heating, followed by acidification, very common reaction, carbene formation will be take place. NaOH CHCl3 के साथ रिएक्ट करके कार्बिन बनाएगा. कार्बिन का अटैक किस पे होगा? फिनॉल के ऊपर होगा. एंड फाइनल प्रोडक्ट वुड बी सैलिसिल एल्डिहाइड. सैलिसिल एल्डिहाइड. This is the salicyl aldehyde. So what is this? This is product S, and we have mentioned the T, R, Q and S, and this is P. ये जरूर मेंशन करना चाहिए आपको क्योंकि काफी सिली मिस्टेक्स हो जाती है इस कारण से. नाउ अगेन क्वेश्चंस ऑप्शंस में भी आपसे कुछ क्वेश्चंस के बारे में पूछ रहा है. कंपाउंड आर ऑन ट्रीटमेंट विद O2 प्रोड्यूस पॉइजनस गैस. व्हाट इज आर हियर? ओह, दिस इज द आर, पॉइजन गैस. मतलब आपको यहां से भी ऑप्शन से कुछ ना कुछ हिंट मिल सकता था पी के बारे में. this will be COCl2, that is the poison gas. So option A is correct. Compound R on treatment with aqueous KOH followed by the acidification gives compound Q. Let's check. Compound R on treatment with aqueous KOH followed by the acidification. What will happen here? A substitution will take place. 3 chlorines will be replaced by OH and water molecule will be removed. So finally you get, after acidification, formic acid. Any doubt? Formic acid will be formed here. So compound Q, what is compound Q? Oh, this is the compound Q. Okay. फॉर्मिक, इधर भी हमने एसिडिफिकेशन किया था, इधर भी हमने एसिडिफिकेशन किया था, तो दिस विल बी कन्वर्टेड इनटू फॉर्मिक एसिड. ये एसिडिफिकेशन जब हमने किया था इसका, तो ये भी फॉर्मिक एसिड के अंदर ही कन्वर्ट हो जाएगा कंपाउंड. सॉल्ट की जगह एसिड ही बन जाएगा. लाइक दिस आर की रिएक्शन जब हमने एक्वस क्यूएच से करी, फॉलोड बाय द H प्लस, एसिड इज फॉर्म्ड. यस, अगेन दिस ऑप्शन इज करेक्ट. कंपाउंड Q डज नॉट गिव टॉलरेंस टेस्ट. कंपाउंड Q, formic acid, very well known compound, it gives tolerance test because of the presence of aldehyde group there. Okay, so does not give, incorrect. Compound S give positive Fillings test. Compound S, where is compound S? Does not, compound S give positive Fillings test. It is an aromatic aldehyde. Can it give positive Fillings test? No, it cannot give positive Fillings test. The compound S cannot give positive Fillings test because aromatic aldehydes cannot give positive Fillings test. It is incorrect. Let's check the answer of this question. What is the answer given? Option A and B. Okay. Let's move on to the next question. It seems to be a little bit lengthy, but let's check. 3 moles of acetone in the presence of dry HCl forming A. A का ऑर्गेनोलिसिस कराया P and Q. P के बारे में क्या बता रखा है? हेलो फॉर्म रिएक्शन फॉलोड बाय द एसिडिफिकेशन. R प्लस S येलो प्रेसिपिटेट, कहीं ना कहीं आइडिया लग रहा होगा कि CH3 कैन बी देयर. ओके, R की रिएक्शन कराई रेड फॉस्फोरस Br2 से वाटर फॉलोड बाय एक्वस KOH and H प्लस. रेड फॉस्फोरस Br2 देख के आपके दिमाग में क्या आया होगा? HVZ रिएक्शन, हेल-वोलार्ड जेलेंस्की, कार्बोक्सिलिक एसिड, कार्बोक्सिलिक एसिड हो सकता है, एंड फॉर्मेशन ऑफ साइक्लिक कंपाउंड देखेंगे. एंड Q, अगेन Q को रिएक्ट कराया है. Q is reacting with LiLH4 followed by the oxalic acid 260 degrees Celsius. And T plus R, T, where is T? T and R on reaction gives M. The very important part, what I am thinking about this question is, if you cannot predict the product A, then question cannot be proceed further. So what can be the product A? What can be the product A? Acetone is reacting with dry HCl. It will form a very famous, very well-known compound 4-one, 3 moles, like this. In the presence of dry HCl, the compound 4-one will be formed. This is the 4-one. How it is formed? Let me tell you here how it is formed. 4-one कैसे बन सकता है? You can use 3 moles in this manner. Here you can remove 2 hydrogens with the oxygen. Again here 2 hydrogens with the oxygen. The complete mechanism can be written as you do like aldol condensation in the presence of acidic medium. So you would get a 4-one. This is the product. Let's move on to the question. The 4-one is formed here, the product A. And product A on organolysis, organolysis के बाद product A क्या बना रहा है? बहुत ही सिंपल है. oxygen, 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 2 moles of acetone would be formed, and this is the product. Next. Okay, what is P and Q? We don't know. Let's take an idea from the next part. P on reaction with NaOI followed by the acidification gives R plus S. Obviously ये तो NaOI से react करेगा नहीं, यही react करेगा, acetone hello form reaction देगा. Easily we can form here NaOI followed by acidification. क्या बनेगा बताइए? CHI3 plus acetic acid, because we have done the acidification after that. Okay, hello form reaction, hello form. Okay, what is S? R and S. This can be S, yellow precipitate. This is R. We should mention each and every product with the symbols given in the question. So here this is P and this is originally this is P and Q, and P on reaction with this, okay, and this is Q. S and R we got. R के बारे में बात कर रहे हैं. रेड फॉस्फोरस, मैं यहाँ से बता रहा हूँ आपको. रेड फॉस्फोरस Br2 क्या करेगा? अल्फा पोजीशन को हेलोजिनेट करेगा, Br आ जाएगा, along with the used water followed by the addition of water. फिर एक्वस KOH Br को रिप्लेस कर देगा. Br को किससे रिप्लेस कर देगा? OH से. तो what would we get? We would get here CH2OH, and the last reagent it H plus heat. H plus का यूज तो यहाँ पे भी आ गया होगा जब सॉल्ट बना होगा इसका. So CO minus COH बन गया होगा. On heating what will happen? Again it is mentioned cyclic compound. Cyclic compound. Esterification would take place. दो मॉलिक्यूल्स के बीच में esterification हो जाएगा और lactide बन जाएगा. Okay. So let's see what is the product here. This would be the product. Very simple. कैसे बनेगा? एक का OH ले लिया, दूसरे मॉलिक्यूल का अल्कोहल का H ले लिया, वाटर निकाल दिया. फिर ऐसे ही करा आपने. Like this you can form in this way. यहाँ से निकालो वाटर और यहाँ से निकालो वाटर. You will get this product. Okay, cyclic lactide. This is the product Q. Let's move on to the next reagent. Q. What is Q? Q on reaction with LaLH4 and followed by the oxalic acid, 260 degree Celsius, product T. तो Q अगर LaLH4 के साथ react करेगा तो क्या बनेगा? Glycerol. Very simple reducing agent. Mild, strong reducing agent. This aldehyde would get converted into alcohol. Ketone would get converted into alcohol. And a glycerol on reaction with the oxalic acid. Very important reaction. Mostly students ignore this part. Polyhydric alcohols. तो आपको polyhydric alcohols पे काफी focus करना है. तो what would be the product? तो here मैं बता रहा हूं आपको इसका प्रोडक्ट कैसे बनाते हैं. ये OH और ये H बाहर निकालेंगे, ये OH ये H बाहर निकालेंगे, जस्ट लाइक एस्टेरिफिकेशन. एंड जो इंटरमीडिएट बनेगा उसमें से दो मॉलिक्यूल CO2 के बाहर निकाल दोगे, यू वुड गेट एलाइल अल्कोहल. हियर डबल बॉन्ड विल कम एंड यू वुड गेट एलाइल अल्कोहल. एंड दिस इज द प्रोडक्ट T. Product T. And T and R. T, look at the T. Where is T? Allyl alcohol. Where is R? This is the R. R and T reaction पे क्या करेंगे? Esterification. और M बना रहे हैं. ठीक है, दिमाग में रखना इस चीज को. Let's check the option. Compound T is diol. Compound T क्या diol है? Mono alcohol. Incorrect. B. Compound A is diketone. Where is compound A? This is monoketone. Only one ketone is present here. Again it is incorrect. Degree of unsaturation of U is 3. Where is U? डिग्री ऑफ अनसैचुरेशन सिंपली बताइए कितना होगा, एक रिंग, 2 डबल बॉन्ड, 3। करेक्ट ऑप्शन। कंपाउंड M इज एन अनसैचुरेटेड एस्टर। कंपाउंड M, R एंड T ऑन रिएक्शन क्या बनाएंगे, एस्टर बनाएंगे अनसैचुरेटेड। C डबल बॉन्ड C है उधर देखिए, ठीक है। तो दिस इज अगेन करेक्ट। लेट्स चेक द आंसर, C and D option. Let's move on to the next question. Dibromide is given, reactant P on reaction with PH3P followed by PHLI, sequence of reaction again, succinylaldehyde, Br2CCl4. Okay. देखो पहले पार्ट से आप लोगों ने ये सोच लिया होगा कि एक विटिग रिएक्शन की बात कर रहा है कहीं ना कहीं, बिकॉज फॉलोड बाय एल्डिहाइड, सम एल्डिहाइड से रिएक्शन हो रहा है, तो आपने पहले ही सोच लिया होगा कि विटिग रिएक्शन की बात हो रही है। तो विटिग रिएक्शन का प्रिपरेशन हो रहा है, 2 इक्विवेलेंट्स यूज हो रहे हैं। तो ये फॉस्फोरस ने यहाँ पे जब अटैक किया होगा ये बाहर निकला होगा, इस फॉस्फोरस ने यहाँ पे जब अटैक किया होगा ये लिविंग ग्रुप की फॉर्म में बाहर निकला होगा, SN2 रिएक्शन टेक प्लेस। PHLI इज यूज हियर, क्या होगा, यहाँ पे हाइड्रोजन है, यहाँ पे हाइड्रोजन है, दोनों हाइड्रोजन को बाहर निकाल सकते हैं, दोनों हाइड्रोजन को क्या कर सकते हैं हम, बाहर निकाल सकते हैं। तो व्हाट विल बी दी प्रोडक्ट, एक्स को देखते हैं हम आगे जाके बनाते हैं नेक्स्ट स्क्रीन पे। X would be like this. Let me show you the question again. Okay. तो this is the X. मैं इसको कार्बन आयन के टर्म्स में भी बना सकता था, ठीक है, हमने डबल बॉन्ड बना दिया बिकॉज रेजोनेंस कैन टेक प्लेस हेयर द रेजोनेंस कैन टेक प्लेस। दिस इज द X। देखते हैं X किससे रिएक्ट कर रहा है, सक्सिनी एल्डिहाइड, सक्सिन एल्डिहाइड। दिमाग से सोचिए इसका स्ट्रक्चर, सक्सिनिक एसिड का आपको स्ट्रक्चर पता होता है, तो सक्सिनिक एसिड का स्ट्रक्चर पता है तो ये भी आपको पता है, बस आपको एल्डिहाइड ग्रुप्स लगा देने हैं, कार्बोक्सिलिक की जगह, कार्बोक्सिलिक की जगह एल्डिहाइड ग्रुप लगा देने हैं, ठीक है। तो अब आपको पता है क्या होगा, ट्राइफेनाइल फॉस्फोरस ऑक्साइड, ये बाहर निकल जाएगा, इधर से ये बाहर निकल जाएगा, एंड रिंग फॉर्मेशन विल टेक प्लेस। अगेन न्यूक्लियोफिलिक एडिशन टाइप हो रहा है, डबल बॉन्ड ये है, ठीक है, रिंग फॉर्मेशन आ जाएगा आपके पास। Y, दिस इज द Y, ठीक है, 1 2 3 4 एंड 2 कार्बन इसके 6 मेंबर रिंग का फॉर्मेशन हो गया। Y ऑन रिएक्शन विद Br2CCl4, Y का रिएक्शन इधर भी हो रहा है और नीचे Na इन लिक्विड अमोनिया के साथ भी हो रहा है। तो Y ऑन Br2 का 1 इक्विवेलेंट यूज किया हुआ है CCl4 के साथ, देखते हैं क्या बनाएगा। 1,4 एडिशन टेक प्लेस बच्चों, साइक्लिक ब्रोमोनियम आयन बनेगा and this double bond will move here and Br negative का अटैक यहां पे होगा। 1,4 एडिशन, आई एम राइटिंग हियर 1,4 एडिशन। दिस इज द प्रोडक्ट फॉर्म्ड हियर। Y on reaction with Na in liquid ammonia gives Z. This is the product Q. This is the product Q. This is the product Q and Na in liquid ammonia. Again the Birch reduction is here. Y का रिएक्शन कराया, Y, where is Y? This is the Y, this is Y, Y on reaction with Na in liquid ammonia, ठीक है। Again Birch reduction, 1,4 addition, you would get this product। 1,4 addition will take place। Conjugated alkene में जब आप Birch reduction कराओगे तो again 1,4 addition ही हो रहा है वो। Let's move Y to Q and Q after Q, KCN aqueous KOH, H plus, NaOH CaO, heat। देखते हैं, अच्छा KCN डाल दिया, फिर क्या है, एक्वस KOH है, OH माइनस लिख देते हैं इधर, फिर क्या है, H प्लस है और NaOH, CaO हीट है, Cn आ जाएगा यहाँ पे, बोलिए सब्स्टिट्यूशन हो जाएगा, OH माइनस हाइड्रोलाइज करेंगे तो COO नेगेटिव, साइनाइड का हाइड्रोलाइसिस इन बेसिक मीडियम फॉलोड बाय द एसिडिफिकेशन, इट वुड गेट कन्वर्टेड इनटू कार्बोक्सिलिक एसिड एंड एट लास्ट क्या किया है, डीकार्बोक्सिलेशन, CO2 would be removed in the form of Na2CO3 and the final product would be cyclohexene, and this is the R, this is R and this is Z. देख लीजिए ध्यान से, X, Y, Q, Z, R and what was the P? P was this. हमने इस रिएक्टेंट से स्टार्ट किया था, ठीक है. कंपाउंड P on treatment with Na dry ether followed by the heating with the 1,3-butadiene gives compound Z. इसको हम यहीं पे ड्रॉ कर लेते हैं. कंपाउंड P follow Na dry ether के साथ वुड्स रिएक्शन हो जाएगा. वेरी सिंपल. व्हाट विल बी द प्रोडक्ट, बताइए. अगर आप फ्री रेडिकल मैकेनिज्म के थ्रू भी जाओगे तो यहाँ पे रेडिकल रेडिकल बना दोगे, आयनिक मैकेनिज्म के थ्रू जाओगे तो Na बना के सब्स्टिट्यूशन करा दोगे, एल्कीन विल बी द प्रोडक्ट followed by 1,3-butadiene. 1,3-butadiene. Again Diels-Hulder reaction. Diels-Hulder reaction. तो क्या होगा Diels-Hulder reaction में, रिंग फॉर्मेशन विल टेक प्लेस, ठीक है. ये यहां पे और ये यहां पे, एंड द प्रोडक्ट वुड बी साइक्लोहेक्सीन. ओ दिस इज अ जेड, देखो जेड ही बन रहा है, ये भी जेड हमारा क्या था, ये रहा साइक्लोहेक्सीन, तो ये भी साइक्लोहेक्सीन बन गया. कंपाउंड Y इज साइक्लोहेक्सीन. कंपाउंड Y, लेट्स लुक एट द कंपाउंड Y. नो, इट इज नॉट अ साइक्लोहेक्सीन. कंपाउंड Z ऑन ओजोनलिसिस गिव हेक्सेन 1,6 डायल. कंपाउंड Z, कंपाउंड Z का करेंगे तो ऑब्वियसली ओजोनलिसिस करोगे तो यहाँ पे क्या होगा, इसका O3 डालोगे, Zn वाटर, रिडक्टिव ओजोनलिसिस, हेक्सेन 1 डायल बन जाएगा, 1,6 डायल. वेरी क्लियर. दिस इज ऑल्सो करेक्ट, दिस इज इनकरेक्ट. मोलर मास ऑफ R and Z इज सेम. R and Z, where is R? R is this and Z is this one, cyclohexene. Both are the same compound, both would have same molar mass. So option D is also correct. Let's check the answer. The answer to given this question is ACD. ACD. Okay. Let's move on to the next question. Oh, next is section 3. It has 6 numerical type questions. Very first question is propine on reaction with NaNH2 CH3Br, ओजोनलिसिस करा दिया है. देन यहाँ से हमें देख के पता लग रहा है कि कहीं ना कहीं बेयर्स विलीगर ऑक्सीडेशन हो सकता है, या देखेंगे क्या होगा. तो आपने क्या किया, प्रोपाइन का रिएक्शन जब आपने कराया होगा NaNH2 से, दिस हाइड्रोजन वुड गेट रिमूव्ड. हाइड्रोजन आएगा तो कार्बन आयन बना होगा, इस पे अटैक करके इसको बाहर निकाल दिया होगा, फिर ओजोनलिसिस करा दिया होगा. देख लेते हैं. फाइनली यहाँ पे ये बन गया होगा ब्यूट-2 आयन. ब्यूट-2 आयन की फॉर्मेशन के बाद आपने क्या करा दिया, ओजोनलिसिस. reductive ozonolysis of alkyne, and this is the A, CF3CO3H. Okay, CF3CO3H. Beers-Villiger oxidation will take place. Here is the interesting thing that कि आप ऑक्सीजन को इंसर्ट कहाँ करोगे, वेयर विल यू इंसर्ट दिस ऑक्सीजन, जो आप ऑक्सीजन को इंसर्ट करते हो. तो CH3CO group has more migration tendency than CH3 group, जिसकी माइग्रेशन ज़्यादा होगी. तो here you will insert the oxygen. Anhydride will form here. And what is this? B, and this would get converted into CF3CO2H acid. अच्छा नेक्स्ट व्हाट इज बी? बी हमने ये बना दिया है एनहाइड्राइड एंड एनहाइड्राइड ऑन रिएक्शन विद बेंजल्डिहाइड CH3CONA. यहीं से हम रिकॉग्नाइज कर सकते थे. वी कैन रिकॉग्नाइज द बी फ्रॉम हेयर कि यार बी के साथ क्या हो रहा है, पर्किन कंडेंसेशन. तो पर्किन कंडेंसेशन में बी क्या हो सकता था, साइक्लिक एनहाइड्राइड होगा. तो पर्किन कंडेंसेशन कराएंगे अगर हम. बी हमें पता है, दिस इज द एनहाइड्राइड. एंड पर्किन कंडेंसेशन कराएंगे तो व्हाट इज दिस सी? सिनेमिक एसिड. वेरी वेल नोन नेम्ड रिएक्शन, पर्किन कंडेंसेशन. I should write here Perkin condensation. This is the product C, and product C on reaction with HBr followed by NaOH and then alcoholic KOH. We can think like this. HBr आएगा तो बच्चों कहाँ पे बनेगा? कार्बोकेटाइन यहाँ बनेगा. कार्बोकेटाइन यहाँ बनेगा तो Br यहीं आ जाएगा HBr के साथ. ठीक है. फिर NaOH डाल दिया CO के साथ, ये CO2 बाहर निकल जाएगा. ओके CO2 बाहर निकल जाएगा तो क्या बनेगा? अभी तक क्या पूछ गए हम? PHCHBr डबल बॉन्ड CH2 अल्कोहलिक KOH निकाल दे. KOH के साथ सब्स्टिट्यूशन हो जाएगा. PH क्या आ गया था हमारा? PHCH2, यहाँ पे CHBr, यहाँ CH2, ये CO2 बाहर निकल गया था तो वी विड गेट एल्कीन. अंडरस्टूड है ना? यहाँ पे पहले Br आया, Br के बाद ये डबल बॉन्ड हट गया था, CH2 आ गया था, COH कार्बोक्सिलिक के फॉर्म में, CO2 के फॉर्म में बाहर निकल गया, फॉलोड बाय अल्कोहलिक KOH, वुड गेट स्टाइरिन. स्टाइरिन बन गया हमारा यहाँ पे. तो दिस इज द प्रोडक्ट D. व्हाट वी हैव टू कैलकुलेट? वी हैव मेंशन A, B, C and D. We have to tell about the sum of number of sp2 hybridized carbon atoms. A B C D में काउंट करिए जल्दी से. कितने इधर? 2. B में again 2. C, where is C? C is here. Here 6 to 8 and 9. Here 6 to 8. 9 plus 8, 17. 19, 21. Let's check the answer. 21. 21 is the answer given. Okay, you can match your answers. Let's move on to the next question. Consider the reaction sequence below. Again, the reaction sequence below is given. What is the first reactant given? C8H8O, Brady's reagent forms an orange precipitate. कह रहा है ये Brady's reagent के साथ रिएक्ट करता है, एक ऑरेंज प्रेसिपिटेट बनाता है. ठीक है. Brady's reagent we know that 2,4-DNP, 2,4-dinitrophenyl hydrazine. बेनेडिक्ट सोल्यूशन के साथ रिएक्ट कर रहा है, रेड प्रेसिपिटेट, मतलब एरोमेटिक एल्डिहाइड तो नहीं है. ठीक है. Br2OH- के साथ करके Br2OH- कहीं ना कहीं लग रहा है हेलोफॉर्म, बट हेलोफॉर्म जैसा प्रोडक्ट नहीं बना रहा है. 2 Br आ रहे हैं. ठीक है. कॉन्सेंट्रेटेड NaOH H+, वी विल हैव टू प्रेडिक्ट अबाउट दी P. तो P को जब आप थोड़ा सोचोगे P के बारे में, एरोमेटिक एल्डिहाइड हो नहीं सकता, बेनेडिक्ट सॉल्यूशन के साथ रिएक्ट कर रहा है, ब्रेडिस के साथ रिएक्ट कर रहा है, यहां पे हेलो फॉर्म दे नहीं रहा है, तो P शुड बी लाइक दिस. Now it can react with the Brady's reagent. It can give positive Benedict solution test. Okay. Now when it is reacting with Br2 in the presence of base, what would happen? There are 2 alpha hydrogens, and the molecular, most important thing is molecular formula is given to you. That means 2 hydrogens are replaced by 2 Br. So what would happen? CBr, Br, CHO, followed by OH minus excess, and then H plus. OH minus excess में होगा तो क्या होगा? सबसे पहले we should have think like this कि both Br will be replaced by OH minus, and on the same carbon atom there will be a 2 OH that will give an unstable product. It will be removed as water. So we would get C double bond O, C double bond O, CHO. Again OH minus excess में है. Cannizzaro reaction, intramolecular Cannizzaro, Cannizzaro. तो आपको पता है कौन सा ग्रुप सॉल्ट में चेंज होगा और कौन सा ग्रुप अल्कोहल में चेंज होगा. एसिडिफिकेशन करा ही हुआ है, एसिड बन जाएगा. OH माइनस का अटैक इधर होगा, तो वी वुड गेट PHCHOH. ये ग्रुप हमारा किस में चेंज हो जाएगा? अल्कोहल में. एंड दिस वुड गेट कन्वर्टेड इनटू एसिड एंड दिस इज द प्रोडक्ट R. ये प्रोडक्ट R होगा. प्रोडक्ट R ऑन हीटिंग, हीटिंग पे प्रोडक्ट R. ऐसा ही कॉन्सेप्ट का एक पीछे भी एक क्वेश्चन आया था. यू वुड हैव सीन व्हाट विल हैपन. द लैक्टाइड फॉर्मेशन विल टेक प्लेस. So what is the lactide here? This would be the lactide formation. And बस यहाँ पे क्या आ रहे हैं? 2 extra phenyl groups आ रहे हैं. 2 extra phenyl groups are present. This is the product T. And R के बारे में क्या बोल रहा है? It is optical active. Yes, it has chiral center, optical active. And R on heating with the NaHCO3 gives CO2. Yes, it can give. Now, what is the question? X1 is the number of pi bonds in P. P के अंदर number of pi bonds कितने हैं? आप देख लोगे X1 3 और 1 4. X2 is the number of pi bonds in Q. Where is Q? Where is Q? This is the Q. Number of pi bonds. X2 is 3 or 1 4. And number of chiral center in R, that is X3. This is 1. You should write like this in the exam as well. Number of stereoisomers of compound T. There are 2 geometrical chiral centers. Okay. So cis and trans form will be formed here. And cis form and trans form में हमें check करना कौन सा optical active होगा, कौन सा optical inactive होगा. Trans form will be optical inactive. Trans is optical inactive due to the presence of center of symmetry, and cis form is optical active because of the absence of any symmetry, plane of symmetry and center of symmetry. So it would have stereoisomers कितने हो जाएंगे इसके? X4 would be 3. तो 3 plus, अब देखते हैं पूछा गया X1 plus X4, X1 plus X4, X1 3 plus 4 divided by X2 plus X3, 4 plus 1, 7 by 5. It would be around 1.40. So let's check the answer. .40. Okay, let's move on to the next question. तो आपको कैसे predict करना था P को, उसकी information आपको given थी. This is the way. And silly mistakes हो सकती थी. बिकॉज आपको X1, X2, X3, X4 को क्लियरली लिखना था. ओके, नेक्स्ट क्वेश्चन इज 26 नंबर क्वेश्चन. हमने क्या किया? OH, NH2, NaNO2 डाल दिया, रिएक्टेंट गिवन है आपको. तो दिस वुड गेट कन्वर्टेड इनटू N2 पॉजिटिव in the presence of this, and this N2 positive will depart as a leaving group and ring expansion will take place, semi pinacolan type, and this oxygen will give electron to this. So what will be the product after the using first reagent? Cyclopentanone. Cyclopentanone on reaction with CH2N2, इसको इस फॉर्म में लिख लीजिए. अगेन न्यूक्लियोफिलिक एडिशन टेक्स प्लेस. O minus CH2N2 positive, again it will depart as a leaving group, and carbocation formation, ring expansion, this oxygen will give this electron, cyclohexanone. मतलब कार्बन एटम्स बढ़ाई जा रहे हैं हम. After that NH2OH is used, NH2OH, NOH, BF3 is used, BF3 is used Beckmann rearrangement. And you know what will be the product of Beckmann rearrangement here? Oxygen will interact with this, and this would get converted into the good leaving group, depart as a good leaving group, ring expansion will take place, and then water का attack हो जाएगा. Very famous compound would be formed here with 7-membered ring, caprolactam. This is the product P, caprolactam. And product Q, this oxygen will get protonate here. Now bond, pi bond delocalization will take place. Here the positive charge come. This methyl group will migrate. Here the positive charge come, and double bond formation will take place. Like this, aromatic compound would be formed here. And question is asking about sum of molar mass of product P and Q. तो आपको क्या करना था, इसका मॉलिक्यूलर फॉर्मूला लिख लेना है एंड इसका मॉलिक्यूलर फॉर्मूला लिख लेना है दोनों का, और दोनों के मोलर मास को ऐड कर लेना है. वेरी सिंपल क्वेश्चन, ठीक है. बट लॉट ऑफ रिएजेंट्स आर गिवन, तो आपको इस मैनर में चलना था प्रॉपर तरीके से मैकेनिज्म के थ्रू. तो यू वुड गेट आंसर इज 235. ओके, लेट्स मूव ऑन टू द नेक्स्ट क्वेश्चन. 27. 2,3-dimethyl butene on reaction with Br2CCl4 followed by the alcoholic KOH. Product A is formed, and further the alkene is given. Let's see. 2,3-dimethyl butene is like this. When it is reacting with Br2CCl4, तो you would get this 2Br आप लगा दोगे, एडिशन, इलेक्ट्रोफिलिक एडिशन रिएक्शन, अल्कोहलिक KOH डालोगे, अल्कोहलिक KOH को यूज़ कर लिया एक्सेस में, तो देखिए HBr डिहाइड्रोहेलोजिनेशन, ठीक है. दिस वुड बी द प्रोडक्ट A after dehydrohallucination, and A on reaction with Na liquid ammonia, again Birch reduction, 1,4 addition, Birch reduction होगा, double bond like this, and this is the product C. Birch reduction में 2 times हो गया इस एग्जाम में कि 1,4 addition का आपने देखा है केस. Very important reaction. And then it is reacting with this, again Diels-Alder reaction. Diels-Alder reaction would take place here like this. This is the product this, ठीक है, ये यहाँ पे और ये यहाँ से. That means ring formation would take place. What will be the ring? Ring क्या होगा देखते हैं. This, and this is the product. After that ozonolysis, reductive ozonolysis, O आ जाएगा यहाँ पे, ठीक है. फिर क्या किया हमने, डाइल्यूट KOH हीट, एल्डोल कंडेंसेशन टेक प्लेस. पहले रिडक्टिव ओजोनलिसिस का प्रोडक्ट बना लेते हैं. CH2 CH CH3 CH2 CH2 CHO and dilute KOH हीट. डाइल्यूट KOH हीट से क्या होगा, आप यहाँ से हाइड्रोजन निकालोगे CH2 माइनस और इस वाले कार्बन पे अटैक करा दोगे एल्डिहाइड पे, न्यूक्लियोफिलिक एडिशन रिएक्शन. हीट भी किया हुआ है, कंडेंसेशन का प्रोडक्ट बनाओगे. कंडेंसेशन का जो प्रोडक्ट बनेगा यहाँ पे आपका फाइनल प्रोडक्ट जो B बनेगा. व्हाट इज आस्किंग इन द क्वेश्चन, सम ऑफ कार्बन एटम्स बताने हैं एंड डिग्री ऑफ अनसैचुरेशन बताना है B के अंदर. वो इजीली कैलकुलेट हो जाएगा, सम ऑफ कार्बन एटम्स एंड डिग्री ऑफ अनसैचुरेशन. एंड डिग्री ऑफ अनसैचुरेशन इन कंपाउंड C. कंपाउंड C में DU कितने हैं हमारे, कंपाउंड C के अंदर DU है हमारे 1. एंड कंपाउंड B के अंदर आपको सम ऑफ कार्बन एटम्स एंड डिग्री ऑफ अनसैचुरेशन बोथ यू हैव टू टेल अबाउट. तो एल्डोल कंडेंसेशन विल टेक प्लेस हेयर. ओके, तो व्हाट इज द आंसर, आंसर इज 11. ओके, नाउ नेक्स्ट क्वेश्चन इज, this is the acid given where n is varying. When n equal to 1, what will be the product? Product is P1. N2, the product is P2. N3, the product is P3. N4, the product is P4. Okay. So first, when n is 1, this would be a malonic acid. एंड द प्रोडक्ट P1 वुड बी, मेलोनिक एसिड का जब हीट करोगे तो आप क्या निकल जाएगा, CO2 बाहर निकल जाएगा, CO2 बाहर निकलेगा तो CH3COOH, N2 के साथ क्या होगा आपका सक्सेनिक एसिड, सक्सेनिक एसिड के साथ क्या बन जाएगा आपका एनहाइड्राइड बन जाएगा, सक्सेनिक एसिड के साथ एनहाइड्राइड वुड बी फॉर्म्ड। N3 द ऑर्गेनिक प्रोडक्ट इज P3, अगेन सक्सेनिक के बाद कौन सा आएगा एडिपिक एसिड, यू कैन लर्न लाइक दिस OMS गैप, ग्लूटानिक एसिड एडिपिक, O N की वैल्यू 0, N1 N2 N3 4 5, N1 पे क्या था मेलोनिक, N2 पे सक्सेनिक, ग्लूटानिक एसिड, अगेन द साइक्लिक एनहाइड्राइड वुड बी फॉर्म्ड हियर, ओके। एंड द प्रोडक्ट P4 कौन सा होगा प्रोडक्ट, जब N की वैल्यू 4 है, दैट इज द एडिपिक एसिड। एडिपिक एसिड में आपको पता है हीटिंग करने पे CO2 भी बाहर निकलेगा, वाटर भी बाहर निकलेगा, एंड द प्रोडक्ट P4 वुड बी साइक्लोपेंटेनोन। नाउ यू हैव टू टेल अबाउट X1 इज द मोलर मास ऑफ P1, दैट इज 60, X2 is the degree of unsaturation in P2, that is 3, and sum of oxygen atoms in product P3 and P4, 3 and 1 4, 63 67. This is the ask in the question. So answer is 67. Now next question is acetone plus phenol is giving A Br2 excess and giving B A on reaction with Na, effervescence आ रहा है, and NaOH CH3 acetone, very common reaction. Every student must have done this question correctly. 2 moles के साथ रिएक्ट करता है HCl के साथ, ये प्रोटोनेट हो जाता है, फिर फिनॉल के पैरा पोजीशन से अटैक होता है, फिर दोबारा से ये प्रोटोनेट OH बाहर निकलता है, फिनॉल की पैरा पोजीशन दोबारा अटैक करती है, अगेन फाइनल प्रोडक्ट क्या बनता है, ये एसीटोन के साथ, ओके, एंड Br2 एक्सेस के साथ, व्हेन Br2 एक्सेस हमने कर दिया वाटर में, एवरी ऑर्थो पोजीशन दिस वुड गेट ब्रोमिनेटेड, यहाँ पे ब्रोमीन आ जाएगा, प्रोडक्ट बी में आपको बता दिया ब्रोमीन आ जाएगा, एंड दिस इज द प्रोडक्ट ए, ये प्रोडक्ट ए होगा आपका, वेरी सिंपल, ए ऑन रिएक्शन विद द NaOH फॉलोड बाय CH3Cl, ऑब्वियसली ए का रिएक्शन जब मैं NaOH के साथ करूंगा फॉलोड बाय CH3Cl, तो ये O माइनस बन जाएगा, O माइनस बन के OCH3 आ जाएगा, तो प्रोडक्ट विल बी लाइक दिस, OCH3. Now what we have to do, you have to calculate number of carbon atoms, oxygen atoms and bromine atoms in A, B, C, all. तो आपको क्या करना है, B के अंदर सारे कार्बन, ऑक्सीजन और ब्रोमीन कैलकुलेट करने हैं, प्रोडक्ट A के अंदर भी यू हैव टू कैलकुलेट ऑल कार्बन एटम्स, नंबर ऑफ कार्बन एटम्स, ऑक्सीजन एटम एंड ब्रोमीन एटम्स, एंड प्रोडक्ट C में भी, दिस इज द प्रोडक्ट C. When you will be calculating, so you would get answer, let's see, the answer is 57, definitely you will get, okay. Next section, this is the last section 4, it has 3 matrix match questions. Let's discuss this, okay. Let's look at the question. In every case I can see dicarboxylic acids are given PQRS, and on heating we know that what will happen, removal of CO2 will take place. In first case, अगर मैं first case बनाऊं, या तो either this CO2 will be removed, either this CO2 will be removed. तो first case के 2 products बन सकते हैं, COOH, अगर ये वाला होगा, this is PH, okay, and the other products can be COOH, and this is H, this is CH3 DH CH3 PH. Okay, what is the relation between these two? डायस्टीरियोमर है, बिल्कुल साफ साफ दिख रहा है, नॉट मिरर इमेज, नॉन सुपर इम्पॉसिबल. प्रोडक्ट्स नंबर 2, दो प्रोडक्ट्स बने, डायस्टीरियोमर है, तो 1 and 4 P के आंसर्स. अगेन इसके अंदर अगर हम जाएंगे Q की बात करेंगे, ये तो P की बात हो गई, Q में भी दो प्रोडक्ट्स आ जाएंगे, COOH H CH3 ET प्लस COOH H CH3 ET. These are the enantiomeric pair. Racemic mixture बनेगा 2 and दो प्रोडक्ट्स तो बन ही रहे हैं, it can be 4. okay. Now इस केस के अंदर क्या होगा, यहां बना लेते हैं इसको, या तो ये वाला CO2 या ये वाला CO2, एक बारी वेज पे रह जाएगा, प्लस दिस. Again these are diastereomer, clearly you can see, very simple, 1 and products, number of products 2. okay, racemic mixture है नहीं, and product racemic mixture है नहीं, racemic mixture is not, it is not a racemic mixture, products 2 and meso है, both compounds are meso, plane of symmetry are present, 1 4 3. In this case what will happen, same concept, COH COOH plus like this, look carefully, this is the COH and this is the COH. Again these are the diastereomer. Diastereomer में ये वाला कैसा है, optical inactive and this is the optical active. तो diastereomer 1 5 and products number 4. Let's check the answer. तो S के आंसर देखिए, S is 4. okay, S is 4, R is 1, R1 इधर भी है, इधर भी है, R4 भी है, R5 नहीं हो सकता, R5 नहीं हो सकता, Q is 2, तो this options are eliminated. और R5 नहीं हो सकता, तो Q is 2, okay, and P is 1. Simply you can check the answer. I have written the detailed solution here. Okay, let's move on to the next question. Option given is G. Okay, this is a question asking about SN2 and neighboring group participation. I can see here. What will happen here? You know that NGP, you know that retention of configuration like SN2 की तरह है, but 2 times inversion होता है, finally the retention of configuration takes place. तो 2 and 4. okay, here दोनों की पोजीशन सेम है, प्योर SN2 की तरह अटैक करेगा, यहाँ पे प्योर SN2 की तरह अटैक करेगा तो 1 हो सकता है. ओके, कैसा प्रोडक्ट बनेगा, फॉर्मेशन ऑफ कायरल प्रोडक्ट, यस कायरल होगा बिकॉज डैश पे आएगा ये, और यहाँ पे भी दोनों कायरल ही आएंगे, यहाँ पे भी हम लिख लेते हैं 5, बोथ प्रोडक्ट्स विल बी कायरल. HCN अगेन क्या करेगा, SN2 रिएक्शन वुड टेक प्लेस हियर, SN2 रिएक्शन में SN2 रिएक्शन और कायरल सेंटर तो रिटेन ही रहेगा ये, तो 1 and 5. ठीक है, इधर नेबरिंग ग्रुप पार्टिसिपेशन भी हुआ है फर्स्ट में, फर्स्ट स्टेप इज नेबरिंग पार्टिसिपेशन. हियर very excellent substrate for the SN2 reaction, you know that Cn minus would attack here and Br minus will be departure. So एक आयरल प्रोडक्ट बनेगा, एक आयरल प्रोडक्ट और SN2 हो रहा है, बट इन्वर्जन तो होगा नहीं, कोई कायरल सेंटर तो है नहीं, तो एक आयरल प्रोडक्ट 3. तो S is 3, S के बेसिस पे हम काफ़ी इजीली चेक कर सकते हैं. तो S4 फर्स्ट ऑप्शन को इनकरेक्ट कर दो, इसको इनकरेक्ट कर दो, S is 3 here, R is 1 and 5, ओके, Q is 1 and 5, तो Q 4 नहीं हो सकता, तो ऑप्शन बी, P is 2. Got it? Now the last question, the B option is given. Okay, last question of this session. इथाइल एसीटेट का स्ट्रक्चर पता होना चाहिए. इथाइल एसीटेट on reaction with pH MgBr followed by hydrolysis, you know that nucleophilic acyl substitution will take place. pH माइनस के 2 टाइम्स अटैक हो जाएंगे, यहाँ से गया डिपार्चर हो जाएगा, दोबारा कीटोन बनेगा, दोबारा अटैक हो जाएगा. What would be the product after the hydrolysis? OH, pH and pH. This is 3 degree alcohol and 3 degree alcohol immediately turbidity दे सकता है इसके साथ. तो P के क्या हो सकता है? 4. ओके, आइडोफॉर्म नहीं देगा, सिल्वर मिरर नहीं देगा, ब्लू कलर नहीं देगा विक्टर मिरर में. इथाइल बेंजीन के साथ अगर बात करें, इथाइल बेंजीन Br2 के साथ करेगा तो यहां Br आ जाएगा. एल्कोहलिक KOH के साथ करेंगे इसको, एल्कोहलिक KOH के साथ स्टाइरिन बन जाएगा लाइक दिस. KMnO4 के साथ वेरी सिंपल ऑक्सीडेशन, बेंजोइक एसिड वुड बी फॉर्म्ड. ये हमने किसके बना लिए? Q के बना लिए. बेंजोइक एसिड बताइए, बाइकार्बोनेट टेस्ट दे देगा. ओके, बाइकार्बोनेट और कोई नहीं देगा. ठीक है. फॉर्मेल्डिहाइड HCHO, कंसंट्रेटेड NaOH बताइए. कैनिजारो में क्या बनेगा? सेल्फ कैनिजारो. दिस सॉल्ट प्लस एल्कोहल, वेरी सिंपल रिएक्शन, बट ऑप्शंस आपके देखने पड़ेंगे आपको. और एसिडिफिकेशन कराया हुआ है, एसिडिफिकेशन के साथ हमारा क्या बन जाएगा? यहाँ पे एसिड बन जाएगा एंड इट वुड गिव बाइकार्बोनेट. 5 हो जाएगा इसका, और सिल्वर मिरर टेस्ट भी दे देगा, 1 भी हो जाएगा. ठीक है. नाउ लास्ट इथेनॉल. इथेनॉल का जब आपने रिएक्शन कराया होगा PCC से तो क्या बनेगा? एल्डिहाइड वुड बी फॉर्म्ड हियर. एल्डिहाइड को जब आपने इसके गिरगनाट के साथ कराया होगा फॉलोड बाय हाइड्रोलिसिस तो यू वुड गेट अल्कोहल, दैट इज द 2 डिग्री अल्कोहल. 2 डिग्री अल्कोहल आइडोफॉर्म दे देगा ये, बिकॉज ऑक्सीडाइज हो जाएगा. 2 ब्लू कलर टेस्ट विक्टर मेयर, RBC. विक्टर मेयर को कैसे याद रखा हुआ है? रेड ब्लू कलरलेस. 3. ओके, इमीडिएटली नहीं देगा. 2 and 3. नाउ यू कैन सिंपली चेक योर आंसर्स. P का क्या? 4. P का 4 दो ऑप्शंस में है. ठीक है. देन Q का 5 इसी ऑप्शन में ही दिख रहा है आपको. आप अपने आंसर्स सिंपली चेक करिए और लेट्स सी द आंसर ऑफ लास्ट क्वेश्चन. इट इज गिवन एज B. तो थैंक यू ऑल. We would be meeting very soon for the paper 2. The next session would be of the mathematics. I hope you have learned lot of things from this session and you would also learn the things from the next session. I am going to invite the Mrigank sir here for the mathematics session. Okay.
Okay, good afternoon, students. My name is Mrugang Jain and I am a teacher with Aakash Invictus, and we are here to discuss the Open Test 2, Paper 1, Maths section, right? So let's start. First is the section 1 with single correct questions. Now you all must have already, aware of the marking scheme and all the sections that are there. So I'm just going to start with the questions directly. Okay, so this is the first question. We are given a set S. This consists of just a moment. Okay, right. So we given this set S, which consists of the elements from -5 to 5, and we get to create the function f. The function should be continuous, and the function is of the form 2 to the power mx greatest integer of that plus the fractional part of 2 to the power nx. So we have to find the number of possible ordered pairs m comma n that we can have. So I think क्वेश्चन को देखते ही सब एक बार आइडेंटिफाई कर पा रहे होंगे कि obviously greatest integer x and fractional part x are discontinuous whenever their input turns an integer value, right? So our aim is that they should not turn an integer. But if m is equal to n, अगर m और n सेम हो जाए तो हमारे दोनों टर्म्स सेम हो जाएंगे, right? So if m is equal to n, in this case the function fx will come out to be 2 to the power mx का greatest integer plus the fractional part of 2 to the power nx. And since m is equal to n, so basically I can just write m as here, and then the function will be a continuous function, right? It will be a linear function directly. So if m is equal to n, the function is always continuous for all values of m and n. And we are given the total possible 11 options for the values of m and n. So here we have 11 cases for this. But if m is not equal to n, then our aim is that the input should not turn an integer value, right? And x varies from 0 to 1. So since x varies from 0 to 1, this input value, this varies from 0 to 2 to the power m. And we don't want that this should turn into an integer, right? So what you can do, if m is negative, and similarly if n is negative, then this input is never going to turn into an integer value and will always have a continuous function, right? So if m is not equal to n, the possible options for m is 5, because we can have m from -5 to -1, and the possible options for n, this is going to be 4, because we've already used one of the values for m, and m should not be equal to n. So for possible options for n is 4, the answer for this case will be 20, right? And well, these are the only two cases, and so the total possible cases that we can have here is for the ordered pair m comma n is 31, right? Let's check the answer. Yeah, the option A, that is 31. Okay, let's move on to the next question. Okay, next question states that we're given the function fx is x square sin x, and gx is an inverse trigonometric function. It's defined only from x as 0 to 2, and we're given a composite function hx. काफ़ी complicated function हो गया hx. Already inverse trigonometric function है. X square sin x भी कोई standard function नहीं है. Okay, we have to find the number of local maxima of hx and local minima of gx, right? And m and n की जो value आती है, so ultimately we have to find m square plus 2n square. So this is our aim. तो maxima and minima बताना है हमें function fx and gx का. What we can do is, they don't want to get into differentiation here because it's already an inverse trigonometric function, and the differentiation of x square into sin x will also not come out to be a very good function, right? It will be a tough to analyze, especially for the composite function hx. And we only want the number of local maxima and minima, right? We don't want the exact points where the function is maximum or minimum. So usually in these types of situations, I think you all must have done quite a few questions, right? We can proceed graphically, right? So let's see. Let's first draw the graph of gx. Gx is an inverse trigonometric function, and I think you guys must be realizing, where do we see this type of function? Cos inverse 1 minus 2x square. This is an identity that you're all used to seeing, right? This is 2 sin inverse x, and that is true when x lies from 0 to 1. But this is going to be minus 2 sin inverse x when x lies from minus 1 to 0. And in this function, what we're doing here is, in the function g, we're just replacing x by x minus 1. So from here we can analyze the function piecewise. This is going to be 2 sine inverse x minus 1. When x minus 1 goes from 0 to 1, so that is basically when x will go from 1 to 2, right? And similarly, minus 2 sine inverse x minus 1. When x minus 1 goes from minus 1 to 0, so x goes from 0 to 1, right? And if you're going to call this function as g, then g is only defined from 0 to 2. So what I'm going to do here, I'm just going to put a strict inequality here so that we have our function g, right? So this is the function that is given to us, and well, we can analyze it graphically, right? I'll just draw the graph. Everybody knows the graph of sine inverse x, right? It's a standard function. It looks something like this. At minus 1, we have the output as minus pi by 2. And at 1, we have the output as pi by 2, right? This is the graph of sine inverse x. So what we have to do is, we have to draw the graph of g here, right? G is twice sine inverse x minus 1. So what we're going to do, we're going to shift this graph, draw the graph of g. We're just going to shift this graph a bit to the right by 1 unit, and that is from when x is 1 to 2. So the graph will look something like this. We'll shift the graph by 1 unit. So in 1 to 2, we'll have this portion of the graph right here, like this. And since we have twice also here, so the graph will extend. It will extend along the y-axis, right? So this output value will now be pi instead of pi by 2. So from 1 to 2, the graph will look something like this. Similarly, from 0 to 1, again, we're just going to shift the graph to the right. And since we have minus 2 here, we'll invert the graph about the x-axis and again extend it. So this shape will be like this when we shift it to the right, and then we'll invert it, it will look like this. Right? So you guys must have done this in graph transformations quite a lot, right? So this is the graph of gx. Quite clearly, we have only one point of minima. So that is our value of n. So n is equal to 1, the number of local minima of gx. Okay. Similarly, we'll go into the graph of fx now. Fx is x square sin x. X square sin x is defined for all values of x. The graph is not a standard graph, right? It will take a bit of time to if we want to draw the graph for all values of x. But see, we don't want to actually know. We don't actually require the graph of fx, right? What we do require is, we want to find the number of local maxima of hx. So to find the local number of local maxima of hx, what do we require? We just need to draw the graph of the function f as long as we have g as the output, because g ka output jo hoga, that is the input of f. So g ka output is from 0 to pi. So f ka graph hame sirf 0 se pi ke liye banana hai. So we just have to draw the graph of f for x belonging to 0 to pi, and that is a rather simple task, because see, x square sin x, the value will obviously be 0 at x equal to 0. Similarly, the value will be 0 at x equal to pi, right? When we proceed from 0, the graph will increase, because x square and sin x both are increasing. And since it's a continuous and differentiable function, at some point we're going to come back down to pi comma 0. Like this. Because at some point, sin x will decrease a lot faster than the way the x square increases. So we'll have some local maxima here, somewhere. Now, if we want to draw the graph of f of gx here, so I'll just draw the graph of gx as well here. We had the graph of gx something like this. This was 2, 1, 0, pi. So this was the graph of gx. See, as x goes from 0 to 1, the value of g comes from pi to 0. So when the input of f goes from pi to 0, the graph looks something like this. So here our graph will be just like this, because when we go from 0 to 1, x goes from 0 to 1, the input goes from pi to 0, and when the input of f goes from pi to 0, we'll have the graph something like this, right? Similarly, when x goes from 1 to 2, when the input of g goes from 1 to 2, the output of g goes from 0 to pi like this, and when the input of f goes from 0 to pi, the graph looks something like this shape. So similarly, we'll have something roughly something this shape here. So again, we can clearly see that the number of local maxima are 2. So the value of m is 2 in this question. So we wanted to find the value of m square plus 2n square here. M is 2 and n is 1. So this value is coming out to be equal to 6. Okay, let's check the answer. Yeah, the answer is 6. Okay. So again, you just have to identify here that differentiation will be a lot longer. It's not a route that we want to take here. If you analyze it graphically, I think some of you can do this question. But yeah, this is a rather tough question, right? Okay, let's move on to the next question. Here we have a piecewise defined function, a rather odd function, right? Okay, and we want to find the value of f of 1 comma 1. Okay, so it's not a standard function, right? We just have to, I guess, just plug in the values. Let's see. F of 1 comma 1, this will be, for now we have m and n as non-zero values. So this will come out to be f of m minus 1 comma f of m comma n minus 1. So this is the order pair that we have. To find this value, we want to know what is f of 1 comma 0. So again, f of 1 comma 0, here we have n as 0 and m as non-zero. So this is f of m minus 1 comma 1, and f of 0 comma 1, we have m as 0, so I'll just apply this. This is n plus 1. N is 1, so this is the value 2. So f of 1 comma 0 is 2, right? So this is f of 0 comma 2. And again, f of 0 comma 2, we have m as 0. So the value should be n plus 1. N plus 1 here is going to come out to be equal to 3. So we should have the answer as option C. Let's check the answer. Yeah. The answer is option C. Right? So it was quite an easy option, right? Okay, next question. We are given the function fx, rather complicated function, right? But we just have to find whether the given function is 1 on and onto. All the options are related to whether it being a 1-on function or onto function. Okay, to analyze this function, 2x is fine, just a simple function. Sin x cos x, well, we can write it as sin 2x by 2, right? Greatest integral x we already know. This is a complicated looking expression. So let's try to simplify this first. What I see here is that, in the denominator we have x to the power 4 minus x square plus 1. What do we know about this? That this can be factorized, but that is not quite helpful because in the numerator we don't have any expression to cancel it out. And what else do we know? In integration, right, we use x plus 1 by x and x minus 1 by x here, right? Algebraic twins, if you guys remember. So that is what I'm thinking here. See, if we divide the numerator and denominator by x square, for this expression, if we divide numerator by x square, I'm going to get x minus 1 by x here. And similarly, if I divide the denominator by x square, this will come out to be x square minus 1 plus 1 by x square. And the greatest integral of the whole thing. So, well, I can convert this function, I can convert this expression as purely a function of x minus 1 by x, right? Because in the numerator I have x minus 1 by x. Let's call this thing as t for now. So this is t upon 4 x square plus 1 by x square. X square plus 1 by x square, you can write it as t square plus 2. Apart from that, we have this minus 1. So t square minus 1. And well, this is t square plus 1. And I can further actually simplify this. It's coming out to be a very good expression. It's 1 upon 4. And this is overall, this is coming out to be t plus 1 by t. we want the greatest integer of this, where t is x minus 1 by x. Now x minus 1 by x, this can take any value from minus infinity to infinity for different values of x. But see, t plus 1 by t, we already know the range for t plus 1 by t, right? At maximum, the range of t plus 1 by t, this varies from minus infinity to minus 2, union 2 to infinity. This is quite a standard expression that we have, right? And well, the 4 times of this is going to vary from minus infinity to minus 8, union infinity to 8. Then if we take 1 upon of this, and 1 upon 4 t plus 1 by t, this is going to vary from, the output will be minus 1 by 2, 0. Union, this is coming out to be 0 to 1 by 8. So essentially what I can say is, see this value, this whole value is always going to lie in the interval minus 1 by 8 to 1 by 8, always, right? So if we add 1 by 8 to this whole value is always coming out to be a subset of, it belongs in this interval 0 to 1 by 4. Always, for all values of t, for all values of x. And the greatest integer of this will obviously be 0. So this whole function is actually 0, nothing else. So what we are left with is 2x, greatest integer x, and sin x cos x. Now I'll just analyze this, what is left over portion. Okay, now to analyze this, if we want to know whether it's 1, 1 and 1, 2. 2x, well, we can obviously differentiate it, it's 1, 1, and obviously it will be 1, 2 as well. Sin 2x by 2, well, it's again a continuous and differentiable function. This is quite a common question, right? 2x plus sin 2x by 2, if the question was just this much, then we could have told that, yeah, this is 1, 1 and 1, 2. But we have greatest integer x over here as well. So what will this do is, see, whenever greatest integer x is differentiable, this whole thing will obviously, fx will anyways be, f dash x will be greater than or equal to 0. So if fx is differentiable for whatever x, right? It's not always differentiable. So if fx is differentiable, so we can say that f dash x is always coming out to be positive, right? Because it will be 2, its differentiation will be 2, its differentiation will be cos 2x, the minimum value of which is minus 1. And the differentiation of this is 0 whenever it's differentiable. And so f dash x is always positive, so it's always going to increase, right? The function will always going to be a 1, 1 function. But when we talk about onto function, the codomain of f that is given to us is all real numbers. Now what will happen is, see, greatest integer x has a jump discontinuity, right? It takes up some value, and whenever we change the function, the value of x has to be just a bit greater, it will jump. For example, see, f of 0 will come out to be 0, right? Because all the terms are 0. And when we talk about f of 0 minus, just a bit lower than 0 minus, this value will be nearly 0, a bit less than 0. Again, this value will be a bit less than 0, but this will be minus 1, right? So f of 0 minus, this is nearly going to be minus 1. In fact, a bit greater than minus 1. So all the values in between minus 1 to 0, you'll never have them in range because f dash x is always positive whenever it's defined. So therefore we cannot say that the function is onto, right? So the function is 1, 1, but definitely not onto. So we should have the answer as option B. Let's check the answer. Yeah, we have the answer as option B. Okay. So yeah, this also was a bit tough to analyze, right? And it will take a lot of time. So this is important that whenever you have such a question in which you're not able to analyze or you think the calculation is going to be a bit lengthy, so probably you should just skip the question, and if you have time later on, you can attempt the question then, right? Okay, so the next section we have multiple choice, multi-correct questions. The first question is, given the set A as 1 to 7, set T be the set of all symmetric and reflexive relations R on A. Pk is the number of relations R, which has exactly 2k plus 7 elements. Okay, so to create reflexive relations, what you require is 1, 1, 2, 2, 3, 3, all these ordered pairs should be in the relationship. should be in the relation, right? So if I write all the possible ordered pairs here, we'll have a total of 49 ordered pairs, right? Because we have 7 options. For each of the elements. So there are a total of 49 ordered pairs here. For reflexive relation, see, all these elements must be present. So I guess these are the 7 elements that should be present in the relation. To make the relation symmetric, if I have this 1, 2, so 2, 1 should be here. In general, if I have I, j in the relation, then j, I should be present in the relation as well. So if I want 2k plus 1, 2k plus 7 elements, 7 elements of these, right? And if I take one of these elements, then the other element should be present as well. So what I can do is, these are 21 ordered pairs in total. And if I take any of these ordered pairs, then their corresponding counterpart j, I should also be present in the relation to make it symmetric, right? So what I can do is I can just take k elements out of these 21. This should be the value of p of k. Because if I take any of these if I take any of these 21 elements in the relation, then automatically their corresponding ordered pair will also be there to make it symmetric. These 7 have to be there anyways, right? So this is the value of pk. Now in the question we're given, we have to find pk. Pk is maximum for k equal to 10. If we put k as 10 here, we'll have the maximum value, right? So this should be correct. Pk is not minimum for k equal to 1. For this value to be minimum, k should be 0 or 21. So D option is correct. And pk is maximum for k equal to 11. That is also true. So answer should be A, C and D. Let's check the answer. Yeah, A, C and D. Right? So if you have your concepts clear, this question should not pose much of a problem. Okay, the next multi-correct question. We have the function from R to R. Fx is defined as 4x plus tan x upon x plus tan x. It's a piecewise defined function. It's not defined at 0. 0, it's defined as 4. We have to find whether 0 is a point of local maxima, local minima, and total number of local maxima and local minima, right? Let's analyze the function at 0. Obviously, you know, f of 0 is given as 2 as 4. Let's see what happens at 0 plus. Since it's a piecewise defined function, we'll have to go to the very basic definition. We'll just look at what is happening just to the right of 0 and just to the left of 0. So when we look at f of 0 plus, see, I can rewrite this as 4 plus tan x by x upon 1 plus tan x by x. So the numerator, it will tend to 5 as x tends to 0, and the denominator will tend to 2, right, as x tends to 0. So f of 0 plus, this should look something like 5 by 2. The limit is 5 by 2, right? So this value goes to 5 by 2. So it's a bit lower. It's lower than f of 0. Similarly, if I look at 0 minus, again I can analyze it in the same way. F of 0 minus, I can rewrite the function like this. Again, tan x by x will tend to 1 in the numerator as well as in the denominator. So again, f of 0 minus will tend to the value 5 by 2, right? So f of 0 is greater than both of them, right? So therefore, you can say that, yeah, x equal to 0 is a point of local maxima. Okay, so obviously it's not a point of local minima. Apart from this, we have to find number of local maxima and minima in the rest of the interval, right? Okay, apart from x equal to 0, the function is defined like this. So you can just differentiate this function. Let's differentiate this. Fx is given to us as 4x plus tan x upon x plus tan x. I'll just rewrite it like this. I'll just break it apart from 3x plus x to make the differentiation a bit simpler, like this. Now you can differentiate it rather peacefully, right? So f dash x, wherever it's defined, it will come out to be the differentiation of 1 is 0. The rest I'll just apply the quotient rule. So I'll differentiate the numerator, keeping the denominator same. then I'll differentiate the denominator, keeping the numerator same. Okay, x is getting cancelled out. We're left with 3 times tan x minus x square x upon x plus tan x whole square. Okay, so this is the differentiation. Now, to analyze this f dash x, what you can do is we can remove trigonometric function from one of the terms at least. What I'm going to do here is that I can take sec square x as common here. So tan x upon sec square x. This will come out to be sin x cos x. And this will be minus x upon the whole perfect square x plus tan x. And sin x into cos x minus cos x. Well, I can rewrite this as sin 2x by 2 minus x. Right, so this will be a bit simpler to analyze. So effectively, my f dash x is coming out to be 3 times x square x upon x plus tan x whole square into, I'll just take this 2 as common from the denominator. So this is coming out to be sin 2x minus 2 minus 2x, right? So sin 2x minus 2x, right? This whole thing is positive for all values of x, but sin 2x minus 2x. See, on the right hand side, whenever x is positive, so this value is negative, right? We know that sin x is less than x. So this thing is, the f dash x is positive for all x, f dash x is negative because this value is negative. F dash x is negative for all x positive. Similarly, on the left hand side, whenever x is negative, so this thing will come out to be positive because we know that sin x is greater than x when x is negative. So f dash x is positive. So that means apart from 0, the function is increasing throughout or decreasing throughout. So therefore, it should not have any other point of maxima and minima. So we already found one maxima at 0. Apart from that, there should not be another maxima. So yeah, the number of local maxima should be 1, but the number of local minima, it should be 0. It should not be 2, right? So D should not be the correct option. So the answer should be A and C. Let's check the answer. Yeah, the answer is A and C. Okay. Okay, the next question. We're given a polynomial function fx. It's a 5-degree polynomial, and the line y equal to 2 touches it at x equal to 1 and x equal to 4. X equal to 4 was also point of inflection of y equal to fx. Then we have to find the local maxima, the local minima, the value of the function, and some have to do some integration here as well. Okay, so इसमें हम क्या कर सकते हैं कि since line y equal to 2 touches the function fx, touches the graph of the function fx at these 2 points, if we want to write fx minus 2, I can say that fx minus 2 function, this should have the point x equal to 1, this should have 1 as the double root because the line is a tangent at this point, right? So you can write it as x minus 1 whole square, and x equal to 4, it also touches the function at x equal to 4, so it should be a double root, but we are also given this is a point of inflection, so it should be a triple root in fact. And the leading coefficient is given to us as 1 here, so we don't have to write any coefficient here. So we already got our function, right? This is the given function plus 2. So we have to find the local maxima and local minima for this function. It's a polynomial function. You can always differentiate it to find maxima and minima. So I think this much you guys can easily do. I'll just do the calculation quickly. When I differentiate it, I'll get, I'm just applying the product rule and the chain rule here. I'll just take the common terms, x minus 1, x minus 4 whole square. I'll be left with 2x minus 8 from here, 2 times x minus 4, and 3 times x minus 1 from here. This is 5x minus 11 overall, right? So this is f dash x. I can easily plot the wavy curve to find the maximum and minima. This is 1, this is 11 by 5, and from here I get 4. And just plotting the wavy curve here, this is the wavy curve. You can clearly see that at x equal to 1, the f dash x changes prime from positive to negative. So that means this is point of local maxima, and this is a point of local minima. 4 is nothing but a point of inflection, as that was given to us, right? So x equal to 11 by 5 is our local minima. That is correct. Obviously it's not a local maxima. Okay, now we have to find the value of f of 2 plus f of 3. You already have the function, right? So f of 2 plus f of 3, I can just directly plug in the values here. F of 2, this is coming out to be 1, and this is minus 8, so minus 6 overall. And f of 3 is, this is 4, this is minus 2 overall. Yeah, so it's coming out to be minus 8. Yeah. C is also correct. Okay, for D we have to do integration, fx into dx from 2 to 6. Let's see. The function was x minus 1 whole square, x minus 4 whole cube. And this is from 2 to 6, right? Okay, obviously you guys can just expand this and integrate, but it will make the calculation quite lengthier, right? What I see here is, well, I can just integrate 2 quite easily, right? From 2 to 6, this will come out to be 8, right? Now to integrate this part, what I can do, what I see x minus 4 whole cube, and I see the limits as 2 to 6. So what I'm thinking, what will happen if I take x minus 4 as t? Because see, dx is dt, so I'm just doing this part right now, right? That is the constant rate. So this will come out to be x minus 1 whole square. X minus 1 will be t plus 3 whole square. This is t cube dt, and the limits are going to be from minus 2 to 2. It's now a rather easier integration to solve, right? Sorry. This is rather easier integration to solve. So I can just expand this. This is coming out to be t5 plus 6t4 plus 9t cube dt from minus 2 to 2. And see, what else you can apply here? We can see that we have t to the power 5 here, right? It's an odd function. So from minus 8 to 8, the integral will come out to be 0, right? Similarly, 9t cube is also an odd function. Its integral will come out to be 0 when we integrate it from minus 2 to 2. So we just have to integrate 6t to the power 4 here, which is a rather easier integration. It will be 6 by 5 t to the power 5. When you put in the values, it will be 32 plus 32. So 64 plus 8. You just have to do this calculation now. This is 6 into 64. This is 40, and this is 384. So this is 424 by 5. Yeah, this is the value that we were getting. So the answer should be A, C, and D. Let's look at the options. Yeah, correct. This is the answer. Okay. So if you were able to analyze initially that, yeah, fx is, we can write it as x minus 1 whole square into x minus 4 whole cube like that. So the question will be quite easier then, right? Okay, next comes the numerical type questions. Okay, we're given this limit that we have to solve basically, right? Okay, let's see what the terms look like. When I put in r as 0 here, I get 1 upon 5 plus 1. When I put r as 1, I have 5 2 square plus 1. Similarly, 2 square 5 2 square, so that will be 4 plus 1, and it keeps on going till I have 2 to the power n, 5 2 to the power n plus 1, right? It's not a standard limit. We can't apply basic techniques that we study here. It does not correspond to anything. But yeah, I see an interesting pattern here. See, in the denominator, the powers are doubling, right? And where do we see this? This is quite a common thing, right? If I multiply this by 5 minus 1, so it will come out to be 5 square minus 1. If I multiply this by 5 square minus 1, this will come out to be 5 to the power 4 minus 1, and this whole pattern will keep on repeating. So what I'm thinking here to do is, if I just multiply 5 minus 1 in the numerator and denominator, it will not help me much, because if I just multiply 5 minus 1 in the numerator and denominator, I'm getting this term. It's not very helpful for me. It's not giving me the sum of the whole series. So instead of doing this, I still want 5 square minus 1, right? So what I'm thinking is, what if I just add and subtract these terms? Okay, so if I take the sum of these two terms, what I'll get is, when I take the LCM, so what I'm getting is 5 minus 1 minus 5 minus 1. So I'm getting minus 2. I'll just write this lone term here as first. ये अकेला टर्म इसको पहले लिख लेते हैं, 1/5 minus 1. इन दोनों का सम, this is minus 2/5 square minus 1. Right? And well, this very well goes with the next term, right? The sum, when you take the sum, it's minus 2 into 5 square, and the 5 square term will get cancelled out. It will come out to be, the sum is coming out to be minus 4 upon 5 to the power 4 minus 1. And well, this can go with the next term, and they'll keep on adding. तो एक तरीके से ये हमारी reaction बन जाती है, right? So and this will keep on, adding. At the end, what we'll get is this last term. When we'll add with the previous term, we'll have minus 2 to the power. We'll always doubling the numerator. So 2 to the power n plus 1 here, and in the denominator we'll have 5 2 to the power n plus 1 minus 1. So when we'll add all the terms, we'll get this. And well, what do we have to do? We have to apply limit n tending to infinity. Well, obviously the numerator is very, very large than the denominator, right? So we'll just left with this term when we apply limit. So the answer of L, the answer of this limit should be equal to 1/4. So 4L should be equal to 1. This should be the answer. Okay, let's check. Yeah, the answer is 1. So it was a good question, an interesting question in fact. Okay, so we move on to the next question. Again, we have to find some limit of a sum. Let's first talk about this expression here. Well, I think this is quite a common question. You guys must have seen this. When you separate it out, this is coming out to be 1 upon r minus 1 factorial minus 1 upon r factorial, and the summation of this is, right? And I think सबको realize हो रहा होगा कि जब हम इधर summation लगाएंगे, the terms will keep getting cancelled out. We'll be left with here 1 upon 1 factorial minus 1 upon L factorial. So we found out this summation right here, right? Then the summation is also on L now. So I'll just apply that summation now. L varies from 2 to n, 1 upon 1 factorial minus 1 upon L factorial. Well, 1 upon 1 factorial is just 1. So I can just add it n minus 1 times. And this minus 1 upon L factorial, well, it's not as easy to find. Let's see. This is coming out to be minus 1/2 factorial, minus 1/3 factorial, so on till minus 1/n factorial. Okay. Then we have n plus 1 minus of this whole expression. We have to basically apply the limit. So I found out this sum, and now what I'm going to do, I'm just rewriting the sum that I found here. I'm just plugging in the values. So so n minus 1, minus 1 by 2 factorial, minus 1 by 3 factorial, so on till minus 1 by n factorial, right? Okay, n plus 1 will cancel out n minus 1. I'll be left with 2 here. And apart from that, I have plus 1 by 2 factorial, plus 1 by 3 factorial, so on. And yeah, now this is coming out to be a great expansion, right? I think you guys must have figured it out by now. I can write this 2 as 1 plus 1 by 1 factorial. So when I apply the limit, the expansion will go until infinity. And what is this? This value will come out to be equal to E, right? So this is what we are given as the value of P. We found out the value of P, so you just have to find out the value of this expression. Our greatest integer of P, that is going to be 2. 2P is 2E upon 2, greatest integer of P is 2. So 2 into 2 minus 1. We have to find the greatest integer of this. So this is basically 2 times 1 plus E upon 3. 1 plus E is roughly 3.72 multiplied by 2. So this is 7.4 roughly. 7.4 upon 3. And the greatest integer of that, that's clearly going to be equal to 2. So the answer should be 2 here. Let's check the answer. Yeah. The answer is 2. Right? Okay, the next question, it's again a question on relations. It's a newly introduced topic in advanced. It says that we have a set A from 1 to 10, and we have to find number of symmetric relations that are defined from PA to PA. PA is the power set. Okay, so power set of A will contain 2 to the power 10 elements, right? We know this. So there are many elements in the relation, I guess. Okay, the relation defines as that A or B is A is related to B only if A and B comes out the whole set. Okay, so see the power set of A, it will contain obviously the smallest subset is phi. Then we have some singleton sets, right? 1, 2, so on till 10. Apart from this, then we have 1, 2, 1, 3, so on. There are going to be a lot of elements, right? 2 to the power 10 to be exact, so 1, 0, 2, 4 elements. And ultimately, we're going to have the whole set A as a subset, right? So this is the power set of A, the relation we're defining from PA to PA. And any ordered pair in the relation is only there when the union gives us the whole set A. So we're given that, the number of symmetric relations is equal to this value. Ultimately, have to find M plus P. Okay, so basically you have to find number of symmetric relations. For symmetric relations, if A comma B belongs to the relation, then B comma A should also belong to the relation. Okay, so let's see what happens. If we take this as the element in our relation, so for this element, if this is the element A, the other element that we're going to take here should be the universal set, right? Because phi union B should be equal to the whole set A. So B can only be equal to the universal set, that is A for us right now. So there is only one possibility, right? If we take any of these singleton sets, for example, if we take the singleton set 1 here, so how many ordered pairs we can form from this? See the element B that we're going to take here, that element B should contain the rest of the 9 elements, right? So for example, if we're going to take the singleton set 1 here, so the element B should contain all the elements from 2 to 10, right? This must be present. The element 1 may or may not be present. So for example, singleton set 1 and this A, the union can be present in the relation, right? So basically, if we're going to take any of the singleton sets, we can take them in 10C1 ways. For each of them, we have the 9 elements should be present, so there is no option for that. But the 10th element, that is the same element that we're taking here, the 10th element may or may not be present. So we have 2 options for that, right? Similarly, if we're going to take any of the subsets which contain 2 elements exactly, we can do that in 10C2 ways because there are 10C2 such subsets. the corresponding element that we're going to take, that element should have the rest of the 8 elements. So for example, अगर हम 1, 2 लेते हैं तो 3 से लेके 10 तक वो सारे एलिमेंट तो होने ही चाहिए, राइट, दे शुड बी प्रेजेंट. 1 और 2 के लिए ऑप्शन है कि 1 और 2 हो भी सकता है या नहीं भी हो सकता है. So 10c2 into 2 square, because for 1 we have 2 options, for the second element we also have 2 options, whether to take it or not take it, and so on till when we finally take the set A, that is our universal set in this case. So 10c10 तरीके से हम A को ले सकते हैं, मतलब एक ही तरीका है बेसिकली. एंड इसके साथ का हमें जो भी एलिमेंट लेना है उसमें कोई भी एलिमेंट हो या ना हो हमें उससे मतलब नहीं है, बिकॉज देयर यूनियन विल ऑलवेज गिव अस द सेट A, राइट. So we can do that in 2 to the power 10 ways. So this should be the total number of, ordered pairs that we can have. So the ordered pairs here we have is, I guess you guys must have realized this by now. This is 10c0 into 2 to the power 0. So this is basically the binomial expansion of 1 plus 2 to the power 10, 3 to the power 10. So these are the total number of ordered pairs that we have, right? So अब इन ऑर्डर्ड पेयर्स में से लेके हमें क्या बनाना है, सिमेट्रिक रिलेशन बनाना है. अब सिमेट्रिक रिलेशन अगर बनाना है तो इफ वी टेक a comma b, we automatically have to take b comma a, right? And well, apart from the set a comma a, the element a comma a, apart from this one, बाकी सबका corresponding एक हमें ऑर्डर्ड पेयर मिलेगा, राइट. दे आर ऑल डिस्टिंक्ट. तो 3 की पावर 10 में से ये एक एलिमेंट अभी के लिए हटा देते हैं, a comma a वाला, अपॉन 2, क्योंकि बाकी सबके लिए corresponding a comma b के लिए b comma a भी होगा हमारे पास, राइट. जैसे इसमें हम 5 comma a एक एलिमेंट होगा, सो वी हैव corresponding a comma 5 also with us, right, in these 3 to the power 10 elements. So 3 to the power 10 minus 1 upon 2, for these ordered pairs, either we take both of them or we don't take any of them. So this raised to the power 2, because we have an option for each possible pairing. And well, for the a comma a element, either we can take it or not take it, so we have 2 cases for this. So this into 2, but here there is one more thing left. See this minus 1 here, and why is this minus 1 here? This minus 1 is here when we are not taking any of these elements, right? All these ordered pairs, none of the ordered pairs we are taking into our relation, then that relation we can't call it symmetric relation, right? Because at least something has to be present in here. So basically minus 1 for this, right? Because we should have a union b as a, first at least some or the ordered pair should be present. So well, I'll just do this calculation. This will be 3 to the power 10 plus 1 by 2 minus 1. So this should be our answer. So when I compare this, I have the value of m as 2 and p as 3. So ultimately m plus p should be equal to 5, right? Let's look at the answer. Yeah, the answer is 5. Okay, it's a good question. Okay, for the next question we have the set A and set B. The equations are very big here, and well, what we have to do is we have to find the number of injective functions defined from set A to set B. Okay, to define injective function from set A to set B, we require set A and set B, right? At least the number of elements in set A and set B. So basically we'll have to solve these equations. Well, at least the good thing is, at least the equations look the same, right? Both the equations are same. The only difference is for the set A, lambda belongs to I, and for the set B, we are given that lambda belongs to 0 to 5 only. Okay, and lambda is supposed to be an integer for this one only. Yeah, for both of them, lambda is supposed to be an integer. Okay, so let's solve this equation. Well, it's a complicated equation, but what I'm seeing here is that, if I divide the equation by this term, I'm getting sort of a quadratic equation. So I'm dividing the whole equation by x square plus x plus 1. This is a quadratic, right? I can just take this as t x square plus x plus 2 upon x square plus x plus 1. I can just take it as t. I'll have here t square plus 3 minus lambda times t plus lambda minus 4 equal to 0. Now this is a quadratic equation, and well, it's factorizing quite nicely as well, right? T minus 1 into what is this? T minus of lambda minus 4. See the sum of roots and product of roots, right? So well, one of the roots is t equal to 1 and the other root is lambda minus 4. Okay. So now basically x square plus x plus 2 has to be equal to 1 or it has to be equal to 4. Obviously it cannot be equal to 1, right? So it has to be equal to 4 only. That is the only possibility, because I think you guys must know this, right? The range of this function, it came in advanced previously as well. You can find the range of this function like this by breaking it out. It will be 1 upon 1 plus x plus half whole square plus 3 by 4, right? So obviously to get the maximum value for this function, the denominator has to be minimum, which is obviously 3 by 4. So the maximum value is 7 by 3. And to get the minimum value of this function, the denominator has to be maximum, which can be infinity. So when it's infinity, we'll get the value as 1, right? And open interval at that, because we cannot have actually the denominator as infinity, right? So this is the range for this function. So t obviously cannot be equal to 1, and we have to find the lambda for which this equation has at least one real root. So if this equation is supposed to have at least one real root, the other root was lambda minus 4. So if this equation was supposed to have one real root, this value lambda minus 4, this should lie in this interval, right? I'm just going to solve it here. Lambda minus 4, this should be greater than 1 and this should be less than equal to 7 by 3. So from here I'll get the value of lambda. So lambda is coming out to be greater than 5 and 19 by 3, less than 19 by 3, less than or equal to, right? So well, there is only one possible value of lambda here, that is an integer, lambda equal to 6. So the set A that is given to us only consists of a single element, that is 6. So similarly, you can talk about the other value. Obviously, if we don't want to have any real root of this equation, then lambda minus 4 should not lie in this interval. As simple as that, right? So lambda minus 4, if we don't want the lambda minus 4 to lie in this interval, then clearly, lambda should not lie in this interval. So lambda can be, for set B, lambda can be less than equal to 5 or greater than 19 by 3, right? But we're given that lambda should lie in the interval 0 to 5. So we have 6 possible values of lambda here. So the set B is actually 0 to 5, a total of 6 elements here, right? Okay, we solved the equations and we have to find the number of injective functions that we can define from set A to set B. Obviously, I mean, set A has only one element, set B has 6 possibilities. So there can be a total of 6 injective functions here. Okay, let's check the answer. Yeah, the answer is 6. Okay, let's move on to the next question. Okay, in the next question we have to solve this 6-degree polynomial, and it should have exactly 3 real and distinct solutions. Then we have to find the value of k. Okay, well, what you can observe here, the coefficients are symmetric, right? Coefficient looks symmetric. The middle is obviously different, but the rest are symmetric. So if we group them, if we group the terms, and how can we group them? If we divide the whole equation by x cube, so I'm just going to group the terms from the first and the last terms. So if we divide the whole equation by x cube, this will be 2x cube and this will be 2 by x cube, right? Similarly here, when I divide this by x cube, this is minus 9x square and this is minus 9 by x square. This is going to be 6x and this is going to be 6 by x. and this is a constant 12 minus k. So if I divide the whole equation by x cube, I will get this. And well, again, see, we're getting a function of x plus 1 by x. So it seems to be a rather repeating topic, right? Okay, so I'll just take it as t. This will be 2 t cube minus 3 times t. This will be minus 9 t square minus 2. This is 6t plus 12 minus k. Okay, 6t is getting cancelled out. I'm left with 2t cube minus 9t square. Apart from this, I have plus 18. So this will be 30 minus k equal to 0. Right. So this is the cubic that I'm getting. And well, I can analyze this cubic, right? We guys can analyze this cubic easily. So if I say, let's say this is some function g of t. To analyze the roots of the cubic, what do? We find g dash t. And we put it to 0. So from here we're getting the two values of t as 0 and 3. Now see, what do we have to do? We have to find the 3 real and distinct solutions of the original 6-degree polynomial. The 6-degree polynomial we wrote it as a function of x plus 1 by x. So x plus 1 by x की हमें कम से कम 2 या 3 वैल्यू तो मिलनी चाहिए, मतलब कम से कम 2 मिलनी चाहिए, 3 भी मिल सकती है, ताकि उधर से x की 3 वैल्यू आ सके. अगर इस क्यूबिक का सिर्फ एक ही रियल रूट आता है, g का सिर्फ एक ही रियल रूट आता है, correspondingly x की मैक्सिमम 2 ही वैल्यू आ सकती है, क्योंकि x में क्वाड्रेटिक बनेगा, राइट? So therefore, what do we want is that this cubic should have at least 2 or maybe even 3 roots, so that the original can have 3 roots, right? So what we can do is, ये हम सबने पढ़ा है, g of 0 into g of 3 we can put it as less than equal to 0. G of 0 is 30 minus k, and g of 3, this is going to be 27 into 254 minus 9t square. So this is 9981 plus 30 minus k. This is 54 minus 27, 3 minus k. So when we're solving it the wavy curve, we'll get k as 3 to 30. So basically, k should lie in this interval, so that this cubic should have at least 2 real roots, and from there we can get more values of x, right? We can have more than 2 values of x. But the question also says that it should have exactly 3 real and distinct roots. Exactly 3 कैसे आ सकते हैं? देखो, x plus 1 by x हमें पता है, हमने previously भी discuss किया है, माइनस इन्फिनिटी से माइनस 2 यूनियन 2 से इन्फिनिटी में होता है, ठीक है? वेयर उसकी जो वैल्यू माइनस 2 है वो सिर्फ x इक्वल टू माइनस 1 पे आएगी, एंड इट्स वैल्यू विल बी 2 एट ओनली द वैल्यू ऑफ x एज 1. बाकी वैल्यूज रिपीट करती है, द रेस्ट आर रिपीटिंग, राइट? सो इफ वी वांट अ रूट टू रिपीट, दैट इज द ओनली पॉसिबिलिटी दैट वी कैन हैव एग्जैक्टली 3 रूट्स. रूट रिपीट कब करेगा, x की सेम वैल्यू कब रिपीट कर सकते हैं? जब 2 या माइनस 2 आर दी रूट्स ऑफ g. So at least one, exactly in fact one of them, either 2 or minus 2 should be a root of g, right? So that is what I'm going to do. I'm just putting in g of 2. I'm just taking the cases here. See, I found out gt was 2t cube minus 9t square plus 30 minus k, minus 9t square plus 30 minus k. So this was the value of gt. So I can make the first case that g of minus 2 should be 0, or g of 2 should be 0, right? Because that is the only case, these are the only possibilities in which we can have exactly 3 roots. G of minus 2 को अगर 0 करके देखते हैं, this is coming out to be minus 16 minus 36 plus 30 minus k. From here I'm getting the value of k as minus 22. But which cannot be true, because see, earlier we discussed that k should lie in 3 to 30, right? Only then we can have more than 1 root for the cubic. So we can just reject this case, right? So g of 2 can be also 0. I will just see this case. I guess the answer should come out from here. This is minus 9 for 36 plus 30 minus k. So k will be 620, 10. Yeah, and this value lies in our defined range, right? It lies in 3 to 30. So yeah, k should equal to 10 should be our answer, right? Let's check. Yeah, our answer is k equal to 10. It's quite a lengthy question, and well, it's not easy to figure out it and make it a function of x plus 1 by x. Even then, you have to analyze a cubic equation. So yeah, this was quite a lengthy question and a difficult question at that. Okay, so next question. F is a differentiable function. It satisfies this functional equation. F dash 0 is given to us. We have to find limit of this function. The limit is also given to us. We want to find the value of a plus 2b. Okay. First of all, when I see this functional equation, we studied this functional equation, right? This is a common result. See, if you put fx minus 1 as, let's say, gx for now, so you'll have this is coming out to be gx into gy equal to g of x plus 1, right? And well, we already know that this is only satisfied for gx equal to a to the power x, where a is any constant. So from here we can easily get the value of the function fx. This is a to the power x plus 1. And to help with the value of a, we are given the relationship that f dash 0 is ln 4. So f dash x is a to the power x into ln a, and f dash 0 is ln 4. ln 4 is, this will come out to be a to the power 0 into ln a, so a is coming out to be 4. So our fx is basically 4 to the power x plus 1. Okay, so we found fx. Now we want to find this limit. Okay, so cos inverse cos 4. Well, we know this is 2 pi minus 4. Sin inverse sin 4. We know sin inverse sin 4. This is this will come out to be pi minus 4. Yeah. So yeah, 2 pi will get cancelled out. This is minus 4 plus 8. So this whole value is actually 4. Okay. So I'll just write down this limit. We given limit x tending to 1 sine of fx minus 5. I already know fx. I'm just substituting that. So this is 4 to the power x minus 4 plus 2 minus 2 to the power x upon x cube minus 8x square plus ax plus b. And this is given to us as ln 4 whole cube, which I can write as, I can write it as 3 times ln 4, right? Because I can use the property of log here. Okay, we have to find the value of a and b here. So what I'm seeing here is that when I put the value of x as 1, this comes out to be 0, this comes out to be 0. So the denominator should come out to be 0, so that this limit exists and is equal to finite number, right? So from here I can say that 1 minus 8 plus a plus b, this should be 0. And similarly, this is one of our equations that we can have in terms of a and b. We want to find the value of a plus 2b, right? So we want to find b as well here. And what we can do is, we can just apply LH rule. I think that will be the simplest approach here. So when I differentiate here, this is the differentiation of the numerator, and similarly the differentiation of the denominator. 3x square minus 16x plus a, limit x tending to 1, this should be equal to 3 ln 4. You know this. When I put x as 1 here, in numerator, this is cos 0. So this is 1, this is 4 times ln 4. This is minus 2 times ln 2. So this is again ln4 basically, right? And this is 3 minus 16 plus a. Now this limit should exist because in the numerator is a finite number. So from here we will get the value of a, right? This is coming out to be 3 ln4, which is directly getting cancelled out. So 3 minus 16 plus a, this should be equal to 1. From here we can get the value of a. A will be 16, 17 minus 3, 14. A is 14 and we already had a plus b as 7. So from here we can also get the value of b as minus 7, right? Okay, a was 14, b was minus 7, so a plus 2b should be equal to 0. Let's check the answer. Yeah, the answer is 0. Okay, so it was not a very tough question. Most were standard results. And well, we can always use LH rule, right? Okay, let's move on to the last section. This is the matrix match section. We're given PQRS 4 options we have to match with. 1, 2, 3, 4, 5 column here, and we have 4 options here. So see, in these types of questions, what you can do is we don't actually need to solve all the PQRS options. We can just solve, at maximum we need to solve, I guess, 2 here, and we'll get the answer. Let's see. Let's take up P here. Limit n tends to infinity n cube, this equals to L. We have to find the limit here. Obviously, I can't integrate this, right? We have x to the power x here. It cannot be integrated in this manner. So what I'm thinking is, obviously we'll have to apply LH rule to find the limit. To apply the LH rule, what I'm going to do here, I'm just going to rewrite this as 0 to 1 by n x to the power 20, 25 x plus 2 times dx upon 1 by n cube. Right, now this is 0 by 0 form, as n goes to infinity, the limit will go from 0 to 0. So the numerator will be 0, the denominator similarly 0. I can apply LH rule here. While applying the LH rule, I'll use the limits so that I can differentiate this easily. It will come out to be 1 by n to the power 20, 25 by n plus 2 into the differentiation of 1 by n, which is minus 1 by n square. And in the denominator, I'll get minus 3 to the power n to the power 4. Right, minus will get cancelled out, n square will get cancelled out by n to the power 4. What I'm left with here is 1 by 3 times 1 by n to the power 20, 25 by n. This is what I'm left with. And see, this is nothing but x to the power x, where x tends to 0. This is quite a common question here. We all have done this question at some point. So we know that this limit will come out to be 1. Right? We find this limit using LH rule again. So the whole value should come out to be equal to 1 by 3. Right? So L is 1 by 3. So 9L should be equal to 3, which is option 3 here. Okay. So we're getting either B or D. So what we can do here is that, well, Q is 2 for both of them. So we don't need to actually solve Q to get the answer. Well, I'll just give a quick hint if you want to still solve 2. What you can do here is that, again, what I'm thinking here is LH rule. And to apply LH rule, we have sin xt to the power 5. So what you can do here is to take a simple substitution here in this manner. Right? If we take the substitution like here, we'll easily apply LH rule and then we'll be able to solve this numerator. Okay. So what I'm seeing here is that r goes to 5 and r goes to 1 here. So if we solve r, we can solve our question, right? Okay, let's solve r. Okay, r is this. It's a lengthy expression. This is 0 to x tan inverse t upon 1 plus t square. I can easily integrate it, right? I'll just write the direct integration. This is just integration of tan inverse x whole square by 2. It's a simple integration plus beta x square cos x plus gamma times x upon x to the power 4. Limit extending to 0. Right? This limit is given to me as 5. Okay, instead of applying LH rule, well, LH rule, because I have x to the power 4 in the denominator, it will take a bit of time. I'm just simply using expansions. When I use expansion here, it will be x minus x cubed by 3 whole square by 2. I'm just writing till the second term because we have x to the power 4 in the denominator. We don't require further terms. This will be beta x square 1 minus x square by 2 factorial plus x4 by 4 factorial. Again, there is x square here, so I don't actually require this term. And apart from this, we have gamma times x. I just group the terms. For x, we have only single term here, gamma x. For x square, we will have 1 by 2 from. Okay, we had alpha by 2 as well here. Yeah. Okay, so for x square, we'll have alpha by 4 here, and beta from here. Right? There is no other beta from here x square. And similarly, x to the power 4 के हमारे पास क्या क्या टर्म आएंगे? एक इधर से आएगा, इनके होल स्क्वायर से आएगा x to the power 4 का टर्म. That will be minus 2 by 3. So minus 2 by 3 times alpha by 4. That will be minus alpha by 6. And एक इधर से आएगा minus beta by 2. And this limit was given to us as equal to 5. Okay. Now obviously this term should be 0, so that the limit exists and is equal to the finite number 5. Similarly, this should also be 0. So gamma should be 0. Alpha by 4 plus beta should be 0. So alpha should be equal to minus 4 beta. And the last term should give us the value of the limit, which is given to us as 5 in the question, right? Now you can just easily solve this. I'll just put the value of alpha here. This is 2 beta by 3 minus beta by 2 equal to 5. 4 beta by 6. So beta is coming out to be equal to 30. So alpha is coming out to be minus 120. Gamma is 0. Okay, so in the question we have to find sum upon 15. Their sum is coming out to be minus 90. Modulus upon 5. This is coming out to be 6. So this is our option 5. And this is what? Option B. So option B should be correct. I'll just still give a quick hint about the S1. What you can do here is that, again, this looks something like a limit of a sum. What I can do here is that we have to find this value till what, n plus 2024. So I guess what you can do here is that you can just add and subtract the missing terms. The missing terms are all finite, and then it will come out in the form of limit of a sum, right? I'll just do a quick calculation here. So when I do this, I can rewrite the limit as this will come out to be summation r to the power 2023. R varies from 1 to n minus the missing terms, which are 1 to the power 2023, 2 to the power 2023, so until 2024 to the power 2023. This whole upon n to the power 2024. So these are all finite terms. The sum is also finite, although very large sum, but still not infinite, right? So these will not matter. The limit will still be independent of these terms, and this will turn into an integration of x to the power 2023, which is quite a simple integration. So this limit will come out to be 1 by 2024. Okay. Well, in any case, we got our answer earlier. The answer was coming out to be B. Let's check. Yeah, the answer is B, right? So you don't actually need to solve all the PQRS, especially in exam. But yeah, when you come at home and for further practice, well, you can solve all the questions, right? Okay. 47th, we have to find number of solutions of this equation. It's not a standard equation, and we're only asked number of solutions. So obviously, what we'll have to do is we can just do this by graph, right? I'll just try to solve this graphically here. what I'm going to do here, I'm just going to separate it out this trigonometric function, because it's going to create a bit of trouble for me if I want to draw the graph for the rest. So I'll draw the graph of this, I'll draw the graph of this, and I'll find the points of intersection. Okay, let's get to the graph. This is not defined at -2, this is not defined at -1. So they'll be asymptotic at -1 and -2, right? And obviously, we'll find out the intercepts here. At x equals to 0, this will be 0, this will be 1 by 32, this will be 1. So the value will be somewhere here, let's say 0, 1 plus 1 by 32, something like that, right? I don't want to draw the exact graph. Obviously, at x tends to infinity, this will be the most dominating term, so we'll have -infinity as the answer. And similarly, as x tends to -infinity, this will still be the dominating term. So at -infinity, we'll have infinity. The graph will be starting from like here, and what I can do is I can just join the points, because at when we have x as just bit greater than -1, this value will go to +infinity, and similarly just -infinity के just left में ये हमारा -infinity हो जाएगा. We have all the points. I'll just join the points here. It's not a very smooth graph, but yeah, the graph will look something like this. I'll just try to draw this graph a bit more smoother, I guess. I'll just lower this point. This was 1 plus 1 by 32. The graph will look something like this. This is the graph of LHS, right? You guys must have studied this, how to draw the graph in application of derivatives. And similarly, you can draw the graph of -2 sin x. It will obviously be starting from origin here, and on the -2 sin x, on the right hand side, it will go something like this. Obviously, it will intersect somewhere here. This is decreasing and this will increasing. So they will intersect at exactly one point here. And on the left hand side, see this value is greater than 1, right? So the graph will be like something like this. It will keep on going, right? It's sin x, right? So it will keep on going. So it's just a rough graph. But yeah, from this graph, we can at least tell that, yeah, there will be 3 points of intersection, right? So there should be 3 solutions to this equation, which is our option 4. So 3 solutions, this will go to 4, P4. We are torn between A and B now, right? So Q is going to 3 here and 5 here. So if we solve for Q, we should have our answer. So we want to find the number of solutions of this equation. And to find the number of solutions of this equation, what I'm observing here, we have, graphically we cannot proceed, because here we have this x square term, which is a polynomial. This includes both x and the trigonometric function. This is just a trigonometric function. So you cannot separate out the trigonometric functions here as I did previously. But if I take differentiation here, this 1, 0, 1, 2 is getting cancelled out, right? If I take the differentiation, that gives me a hint of maybe a way to proceed. So let's check. If I take this as the function fx, so f dash x, this is 2024x minus sine 1012x minus 1012x cos 1012x. So I'm just applying the product rule and chain rule to differentiate this. So this is the derivative of the function. Sine is getting cancelled out. Okay, I'm getting a very good term here. If I take 1012x as common, I'll get 2 minus cos 1012x. Right, and now if you realize, this is always positive for all x, right? So f dash x, this is going to be positive for all x positive. And similarly, this is going to be negative for all x negative, because f dash x just depends upon x. So the function is increasing after 0 and it's decreasing before 0. Okay, and what is happening at 0? F of 0 is coming out to be This one is the fx. So f of 0 is coming out to be minus 1 upon 1012. Right? So what is happening? If I draw the rough graph, what is happening? At 0 we have this value 0 comma minus 1 upon 1012. To the left the function is continuously decreasing, so it will look something like this, because at minus infinity the value is infinity, right, because of x square. Similarly at infinity the value is infinity because of x square again. So this is equal to 0 at exactly 2 points. We can get that by intermediate-Wally theorem, right? So the number of solutions of this equation is 2. So this should be the third option. Yeah, A. So A should be the correct answer. So I already got my answer, but I'll still give a quick hint about the rest of the options. When you want to find the limit fx upon 1 minus x cube, you can simply find RHL and LHL here, right? You can open this mod, and similarly, I'll just solve RHL here. For RHL, let x equal to 1 for RHL. We have 3 by 2 here. The denominator will obviously be x cube minus 1, because x cube is greater than 1. And if I just open this mod, it will be x5 minus 1. This will be opened as it is because x to the power 4 is greater than 1. Similarly here, x to the power 4 minus 1 when I remove the mod. And for the last one, x to the power 5 minus 1. So you can simplify this expression. X to the power 5 is greater than x to the power 4, so mod will open as it is. You'll cancel out a lot of terms, and you'll have 2x to the power 5 minus 1 upon x cube minus 1. Apart from that, we have 3 by 2 here as well. Now, you can clearly see as we apply limit x tending to 1 here, you can do either by standard limits, x to the power n minus a to the power n, or you can also apply L'Hopital here, right? You'll also get the answer. So the answer for RHL, it's coming out to be 5. And since you don't have any options which say the limit does not exist, so the limit should exist, and it should in fact come out to be equal to 5. If you want, you can solve the LHL in the same fashion. It should come out to be equal to 5, right? But in exam C, we have to be smart about time, right? Because we have a limited amount of time. So you don't want to waste time like this. If you don't see any options which correspond to limit does not exist or none of these, so you can just directly find RHL and you can say, yeah, this is the answer, right? Okay. Similarly for last one, we have to find f of 2 gx where fx and gx are defined and given to us, and we have to find its value. So I'll just quickly try to find this value. Let me just find a place where you can write. Okay. So f of 2 gx, gx is this. So f of 2 gx is f of cosec x, obviously, because gx is it's not piecewise defined, and well, this will be greatest interior to cosec x, but this is defined only when cosec x lies in this interval, right? And well, cosec x does not lie in this interval. In fact, there is only one value where cosec x can be equal to minus 1. So this function is only defined for one value of x when cosec x is minus 1. So its greatest interior will come out to be minus 2. And we want to find f of 2 gx plus 2, so this will be 0. The answer to the last part will be 0. Okay. Okay. Anyways, we got our answer previously. The answer that we had was, what was this? A. So let's check the answer. Yeah, the answer is A. Okay. Okay, let's move on to the last question. If fx is given to us as piecewise defined, then we have to find f of fx for x belonging to minus 1 to 0. Okay, let us solve this. F of fx, this will be f of x plus 1 when f of x is negative, and f square x minus 1 when f of x is greater than or equal to 0. Right, I've just put in the function f instead of x here to define the composite function. Now, interestingly, we don't want to completely find f of x. We just want to find f of x when x belongs to minus 1 to 0. तो जब x minus 1 से 0 में है, मतलब x negative होगा, तो function क्या होगा? Function can only be x plus 1. And for x lying in -1 to 0, x plus 1 will be positive. So we have this case. So जब अब x हमारा -1 से 0 में होगा, x plus 1 is positive, so we will just substitute x plus 1 here, and this is our function, the required function, right, which is x square plus 2x. So this should be the answer for P part. Let's check. Yeah, x square plus 2x is our second part. We have A and C, two options that correspond to this. Okay, Q is different for both of them, so we just have to solve for Q now. Q says that f of 2 tan x upon 1 plus tan square x. This is given to us this expression. We want to find fx for x in -1 to 1. Okay, so this is a trigonometric expression. So what I'm thinking here is that I'll just write it as tan x as t to simplify my calculation. It will save me a bit of time. This is cos 2x. I want to write everything in terms of tan x, right? So cos 2x is 1 minus t square upon 1 plus t square. Sec square x is 1 plus t square, and this is 2t upon 2. When I take the LCM here, this is coming out to be 2 upon 1 plus t square, and this is t plus 1 whole square upon 2. So this is coming out to be I cannot cancel this out. Rather silly mistake on my part, right? Okay, so what I can do here is I can just expand the numerator because I want to convert everything in terms of 2t upon 1 plus t square. So I can separate it out, and I got my expression 2t upon 1 plus t square. So basically I can say that fx is, you guessed it, 1 plus x square. Let's match our option. 1 plus x square. Just a moment, let me check. Sorry, no x square here, right? This is just 1 plus 2t upon 1 plus t square. So this is just 1 plus x. Okay, so this is our option 3. So we got A as our answer, right? Okay, we'll just quickly go on to R and S. We already have our answer as A. F of x plus y plus 1 equals to square of root fx plus root fy. What I can do here is that, well, again, f of 0 is given to us as 1. Again, we just want to match the options now, right? Because we've already done with this part. What I can do here, if we write, let's say x and y as 0. We take x and y as 0 here. So f of 1, we'll get the value of f of 1 here. Since f of 0 is given to us, f of 0 is given to us as 1, so f of 1 will come out to be 4. And well, there is only one option that is matching, right? 4. R goes to 4. So you can do this question very quickly in this manner. And similarly for the last one, for the S part as well, f of x equals to greatest unit of x plus 4. Well, this is a constant actually, right? For all x in 4 to 5, this is 1. So this is basically 2x plus 3. We just have to find the inverse. So yeah, this is quite an easy question. So its inverse will be, this is the function. So just replace x with y. So the inverse will be x minus 3 by 2, which is our first option. Again, in the option A we have, right? So again, in matrix match, be mindful of the options that you have, because you just have to match the option in the exam, right? When you come back at home, then you can practice the rest, but let's try to save your time in the exam. So just match the answer. Yeah, the answer is option A. Okay. Okay, so this was all for the math section, and I hope you guys enjoyed our presentation, and I hope you guys learned a lot, and please be confident in your exam. This paper was quite tough, overall. But yeah, there were some easy questions, especially, you know, the last matrix math that we did, that you could have done that very quickly. So, you know, whenever you face a tough question, especially, you know, at advanced DSS exam, so don't lose hope. You just, you know, power through, just leave the tough questions for later, and, you know, make sure you attempt all the easier questions, right? Okay, I will meet in the discussion for paper 2 now. Okay, thank you.